For one new day. We will start our program of this morning program with the conferences. Welcome everyone. I thank also the ones who are attending to this conference remotely. Thank you for your company. I would like to tell about our sponsors, which are Apex Brazil, Brazilian Navy, Brazilian Army, Brazilian Air Force, Defense Ministry, and the federal government. Also, we have the support of UNESCO, the Secretariat of Tourism, Secretariat of Science, Technology and Innovation of the Federal Cluster Tecnológico Naval from Rio de Janeiro, Brazilian Institute of Entrepreneurship Relations of Vila Boas Institute, Technological Center of São José dos Campos, and Smart Defense. I will tell about our other sponsors, John Cockery's, General Dynamics, in Golding, Taurus, and CBC. Silver Ares. I would like to tell here also our alliance with the Defense Industry Union, CINDI, CSTM 2021 has also the sponsorship of a Brazilian Associate of Hotels and Convention Visitors Bureau. We have responsible, secure tourism stamp, so to safeguard your safety and your health, and also Visa and Ministry of Tourism stamps. CSTM 2021 is idealized by Prospectar Brazil events. You can download your app and to follow all that is happening in this event. You can also follow our actions through the main social networks. So to start our activity this morning, I would like to inform you that our main conference is the digital conference CSTM, and so we are going to present now the presentation of the General of Division Air 1, Luiz Antônio Duizzi Brito, of the Secretariat of Defense Products of the Ministry of Defense. Please come to the stage, Mr. General. The theme is COVID-19 and defense industry. Good morning, everyone. The theme seems a little complicated, but when we take a walk through what has already been done, we can understand that when we fight for innovation and science technology, we generate security for a high technology nation, mobilized according to each necessity and according to the historical moment. So let's take the media regarding science, technology, and defense products that are available in Brazilian industry. Video being transmitted. We may start through an observation involving our defense legislation. You saw the grouping there. Someone would say Gripen is a Sweden airplane from up to the 16th, but from the 16th on will be produced in Brazil. Because of that, any defense contract has an offset with the transference of technology that will permit us to fly higher when RJ 145, 170, 190 went all over the world. It came from the technology developed with Brazilian and Italy that made the airplane less costly. And so we have to understand the defense industry permeates all society sectors through their rulerships. Why didn't the country buy this and this equipment? Brazil does the offset. Do they want to transfer technology so it doesn't interest us? We don't want to be slaves. We want to have technological autonomy because you may understand one of those days that COVID came in and other problems, you may have other problems in the future. Let's see how it tells us. Look at the size of the country that we've inherited from the Portuguese. With their ways, they could maintain us with one language, territorial integrity, and we have 10 countries, borders with 10 countries, 17,000 kilometers of borders, and that was the country we have inherited from our predecessors. We hear, how can this country have solutions for this or that? And you see the proportion of our territory. See how much did we evolved and won in such a little time. Brazil, with all its difficulties, has a social health available for all society. Even very healthy countries do not have that type of health. See our defense industry. This is the history of our defense industry. Again, the inheritance from the Portuguese that we cannot make fun of, because over there, just to give you an idea, Mary the Crazy was the one who has found the Institute of Engineering. It's the oldest engineer institute in the Americas. And even if the explosive industry comes from very long time ago, what was the difficulties we had? Financing. We are correcting that now. Another problem was the dependency of imported equipment, and then you are under embargoes. That's why technology is determined so that we can face our challenges. And then defense ministry on the 23rd of November, the secretary has specialized one of its departments so to promote integration of the defense industry along with other strategic projects. Why did we mobilize a bid? There was a presidential decree on a Sunday, 12th of March, I don't remember for sure. It wasn't difficult. What was happening by that time? Value, global chains, disruption. You could not send products for that or this place. There was less dependency from products, from some products. We now, for example, can use alcohol in other forms. How can you strengthen your industrial base in a context like this? When we talk about disruption of the, the global chains of value, we may talk about two themes, health and defense. If an industry from outside of the country, a former friend of yours, from whom you would have technical and material, could not send us valves for the breathing equipment. Defense and health is just like a party. It's each one will have their fun, their own fun. By that time, we were working in three lines, compensating the reduction of demand, so to maintain jobs and the productive capacity. You take 2 decades to keep our structures. We could have to make sustainability and recovering of the companies after the crisis. For us, the crisis is over, although it's going on. It's still going on in other places. Strategically, we have to preserve the capacity of acting, of bid. If we can, what is that the breathing ventilators has to do with Army? Biosecurity and bioprotection is a chapter in defense. You talk about a biological war, a chemical war, and everything are all those things are chapters of defense involving the maintenance of life, because those are items under which we have international treaties, because there has been many errors in humanity that generated catastrophes and calamities. Well, we had to find financing for our industry and maintenance of triple pillars, which are academy, govern, and industry. Govern demands, academy develops, and the industry is qualified to that. So that is the importance of have those institutes, which are the Senai groups of innovation that were determined, that were very important. Senipem also for the development of equipment and testings, the Catholic Institute of Porto Alegre, and other institutes as the University of Brasilia, one, the joint efforts so to develop equipments, because our friends who are supposed to give us equipment didn't give us those equipments. And in 120 days, we got it. And so we had to have a tax system, isonomic tax system. If I don't protect our industry from dumping and other things, I will have the internalization of products that are low quality, low cost, and if I don't export, and then I have an observation to make here, I have to export. Otherwise, I won't heighten our technological competency. If I don't expose myself to the international market, I'm not sure if I'm up to date or not. How to mobilize the structural base of defense. In the Ministry of Defense, in the Secretariat of Defense Product, we communicate and participate in joint events with proposal or legislations with the councils and defense committees of the federations of industries. For example, you have Condefense of Amazonas, you have the committee of the CNI, Confederation of National Industry, Dr. Glauco Cortes is the coordinator there, and then you have Goiás, Minas, São Paulo, Rio de Janeiro, Bahia, Rio de Janeiro, Paraná, Santa Catarina. All those committees have worked in a joint effort to mobilize industry in a way to gain competency, to develop equipment and health products that from what we had demand of for our huge country. Also, we have associations and unions that are specialized. We work with a BING that is already working with the defense industry, the CINTI, which is the union of the Federal Industry of Defense, BIMAC, which is an industry and an industry of machine, ABIKIN, which is a chemical industry. We're working with all industries, so to map ABIMO, for example, is Brazilian industry of health and odontological material. ABIFER also is for train material. So in less than 15 days, we had a conference, an online conference, a 3-hour online conference with everyone, and we started talking about solutions. There was no disharmony in that conference. This is a characteristic of our country. All of us was on without asking about costs. We're talking about solutions. Everyone were paying their share. Defense were paying transportation. The industry would buy materials, spare materials were getting into there. So there was a natural mobilization. So we think, is it that we can see that Brazil is mobilized and to make innovation in a high capacity, but just who has knowledge can innovate, and that presupposes university innovation centers, and then I will highlight the Senai systems and also the University of Brazilian one. Various high technological industry that swiftly was solving our problems. So in less than 15 days, everyone knew what challenge they had to face and to overcome. What is interesting to us here is the conclusion, how not to get into this trap again. It's a cyclical trap. 50 years, 30 years, sometimes it is biological, sometimes it is radiological. When we had the Goiânia problem, it was a disaster, a radiological disaster. When we have a flood, it is a climate problem. And now we had a biological catastrophe. The industrial defense and the materials are all mobilized. So, and army and the armed forces may respond to any emergency. Biological defense is defense. It's a pillar of the defense. We have an institute. Damasco, please help me. You who engineer, what's the name? The Institute for Chemical and Bacteriological Defense was certified by the World Organization for Chemical Weapons. That's the first institute in Latin America certified. And why did it happen? Because we act according to the action that comes from there. When we started, Márcio was a little younger. We bought all material in investment. We have invested in that institute. It has been qualified in terms of equipment. Look at the result today. We have institutes in Brazil. They're apt, capable to prepare and train people to identify those problems. So everything happens from actions, preventive actions. We have to look at the strategic side. The first moment we remember is taking our personnel from Wuhan. We took Brazilian and Colombian people that was there. If there was space in the airplane, they got a ride from us. Nobody knew what to do. Everyone was had a quarantine in Annapolis. No one had COVID, but that was a shocking moment. No one knew what to do. So we had a awareness campaign started, support to the health bodies. We not only have trained the civil and public area, but also our own doctors and nurses, our health personnel of how to deal, how many intensive UIC doctors did we have? X, and then we started having 5X. This was very fast response. Now we have to make a list of all the structures that have done their homework. Let's remember the blood. We have a lack of blood. So we have mobilized donations and trained. We had defense unities of chemical and radiological defense in Rio de Janeiro, one here in the operational brigade, and that's all. And we had to act nationally. So that the first amount of culture that we had done for the World Cup, we had to swiftly do a work to adapt that work for the new tragedy. And so there was decontamination of public areas, huge number of public areas, but the execution needs previous planning, so we have to generate capabilities inside defense in a way of surviving adverse moments, whatever happens. Our vessels in the health area, in the food area, all of them were there in the terrain, mobilized. Since the Second World War, our crowd, our effective people, that we had more death during the COVID time than in the Second World War. In the Second World War, we had 1,800 people, and now we have 600,000 people. You see that airplane with military technology carrying medication, material, sick people, the machine from various industries doing mask testing equipment. All of that has been an adaptation happening in our industry that have changed their profile. Tauro, CBC, we have companies here that have changed their profile production, so to participate and be mobilized and produce to support. So let's see how do we work. We act jointly with MCTEY, Ministry of Science, Technology and Innovation, and Visa, which our agency was in the same situation room in Palácio do Planalto. We start to approach the technology to build fence, support to new initiative in testings. We are homologating a system. So to test through the saliva, if you have COVID, chikungunya, prostate cancer, we have already done that. It's tested, and Masi was one of our scientific prey. He was there 4 times there, contaminated and with no symptoms. We thought it was a bug in the machine, but we have tested him 4 times, and he was always tested positive for COVID and said, well, he was working, and every time that we tested him, he was positive. This is All this testing was Brazilian driven industry. Another research was in the Universidade de Uberlândia during 15 years through, um, and we have that done. Also, Niobe eliminates a virus that you put in the mask that was developed by the University of Belo Horizonte in its nanotechnology center, already developing products because that is resources that we generate. So these triple pillars have to be working. And the Ministry of Science, Technology, and Innovation was financing that. So the crisis helped us to start moving. There was a series of approvals of concepts in detection systems through ozone and chlorine. That biological issue does not end here. But now we have knowledge how to build ozone tunnels, so to eliminate. Many countries have installed that, some others didn't, but sometimes they have decontaminated people upon their leaving the environment, taking the safety equipment, and then they would be contaminated at home. So now you have to decontaminate with your uniforms, with your all security systems, and then after you have another session of decontamination that can maybe apply to any environment. You may use by ultraviolet, but the simplest one is the one based with chlorine, developed by Symantec of Bahia, and the other developed by Ozone through Joinville industry on technology. Well, we had another problem where to buy those medications. How can we do that? I know. Even a tape, the medication tape, how could we map that in Brazil? We had to work on that. How could Brazil identify the virus? We have the NB3 laboratories. For example, Ananindeua laboratory in Pará, the state of Pará, created by Rockefeller Foundation. That's a detail. ITA and Ananindeua have been founded in the same time, the same era, by 10 engineers, 7 from beach and 7 from the air forces. And this Ananindeua that specializes in virus has 120 viruses mapped and kept there and under control, of course. That's why it's not. That's why nobody knows exactly where COVID started, because the laboratory over there was and before, and so that wasn't possible to get off there. It's impossible the way it's encapsulated. It's impossible for it to escape. Without that, it's not possible for us to make a vaccine in Brazil because we cannot use the virus. So we are restructuring within the Ministry of Health Ministry, and Anvisa is in this process, all network of NB3, NB2, and now we're going to have the NB4 that we have for animals with tails and cerrados animal. With this, we can have animal vaccines, but we still have to solve the human vaccine. And support for logistic problems in importation of materials. It is important. In Belo Horizonte, we had an industry that has exploded in growth just in the area of international transportation. This will keep growing. So this company has been qualified and certified and is already very big in this area. What did we do? Simple solutions. The Defense Product Department of the Defense Product Secretariat has certified companies, had auditions, and built a data bank. In 1 week, a data bank was built to observe where it was being fabricated and the capacity of fabrication to every product we needed. We have built this system, and who was available for? We have to democratize our knowledge. We start talking to CONAS, which is the National Council for Health, and COSANEM, which is the Council of Municipalities on Health. And now we have a site at the Ministry of Defense that is available, that makes possible to find a company that is producing whatever you need. You don't need to import or find it in a very far away state. Oh, the interesting fact on that was 147 products is already available, and in 563 companies. Through this mapping, I had the contact, interest. We knew how we could get there, and in a very swift way, we could facilitate the procurement. The the fight in the beginning was just for alcohol. Through mapping, we found a company, a very good one, in Uberlândia, very close to here. And they had this product. It was the first procurement of the Ministry of Health. And after we've been developing the problems of other products, for example, that one that was supposed to mixture to the alcohol to make it turn into a little solid alcohol, a gel alcohol. And so we avoided paying royalties and things like that. Nice, we have a nuclear engineering right here. Now we have a catalog for innovation of all those biosecurity products developed under the COVID crisis from Brazilian technology. We have 2 fans. I'm not going to talk about the company that's developing that, so not to make marketing. One has developed a fan, mechanical fan. Is that possible? Yes. 40 years ago, we didn't have anything electronics. In state of Rio Grande do Sul, but by the way, a very poor country like the United States has done millions of that. So when you had a pulmonary ventilators, you could use that mechanical ventilator that could be used with no electricity. Our intensive doctors could use it. The automotive industry could connect all those ventilators in a way that one intensive unit doctor can control 51 of them. A very young doctor can control all of those ventilators. And in a Wi-Fi controlled system. So the builder, the company, knows that instrument is going out of work. One ventilator of that cost $90,000, and now we got the price down to $30,000, and we cannot import any valve. We don't need to import any valve. We also had to recuperate some ventilators. You see those little electronic machines over there? We have shown a tower, a radar tower in that video. Well, that company has a super print that when you are in an ICU behavior and you need a ventilator and a heartbeat machine, you have an infusion bomb. That was lacking a plaque. So we talked to all builders or developers, even on Sundays. And there's this Romeo and Juliet, which is a pig, a testing pig, that was shown breathing through their ventilators. So when he said there was a problem in the infusion plate, I've talked to the owner of the company, and Brazilian developed that bomb for the ICU units, and we didn't have to buy that anymore. All our automotive industry has got into that fight. The Ministry of Economy, there was our Air Force airplanes going, medications for Macapá, Recife, get protection equipment in other states. So all our systems are involved without thinking about costs. They were producing around 6 months of work without thinking about costs. See the industries there around that. See all the little companies, BMW, ArcelorMittal. We have some loss, of course. We need to produce. We have to substitute. Everyone got into this fight. I have reports, detailed ones. Everyone was working on that. From ArcelorMittal, Sideri, metal industry, and the Senai system too. The Army has lent us an artificial pulmonary machine. We had lacking. The Army hospital has lended to one of them. So the ventilators were done. When we reach 80 million personal protection equipment, now we have even more, 6 companies producing ventilators. We are exporting ventilators and participating in international events, participating in their selling. Our Anvisa certification system is very safe. When we sent our ventilators for testing, it has beaten the international ones that had international certified ones. Whoever is paying attention, when there was the accident with Boeing, the person that has made the certification was a type of pirate that he was in jail in the United States. So the armed forces, we have to vaccinate them. Have to vaccinate our army. We have to transport vaccines. So we got into the national program, into immunization. We have to build vaccination centers. Since February, January, what's our share? Brazil has 35,000 centers for vaccination under the SUS systems. Brazil doesn't produce IFA yet, but it's starting to produce that by Oswaldo Cruz foundations. But we already have the immunizing principle being produced here. So we had the Army, the Air Force, the Navy starting that movement. On the borders, we had to vaccinate this border in, this border out, because without vaccination they couldn't get in. So sometimes we have a border that is there is just a street, and also the indigenous vaccination that is recognized by the Health World Organization as a fantastic system. I'm going to show you a map so that you can understand the level of complexity of that Brazilian case that has a huge population of indigenous people. You have the Indian tribes divided to isolated tribes, non-isolated ones. There is sanitary district. So up to that date, we have already attended 280,000 indigenous peoples. Who has transported them? Was that on parachute? No. We could do that, but it wasn't. We had helicopters. There were maintenance. They had their maintenance in a Brazilian industry. It was born not because we're nice, just because of offsetting. When we start to buy, when we procure helicopters, the once was called Eurocopter, Helimator. Today we call them Airbus. Through offsetting, we developed the capability to develop them in Brazil. So if I didn't have the capability to fly, we didn't have the capability to transport that medication in calamity situation. So we developed the Secretariat for Indigenous Health. By that moment, we already had that level of vaccination. This is our continental country. When everybody works together, we have results, state, private, initiative, academy. And how was that coordinated? There were joint command to operating Army, Air Force, and Navy to use all instruments. Air Force has terrestrial means, Marine, the Navy has helicopters. So there was a joint command. For example, in the Amazon, the Amazonic Command attends 7 districts. The Joint Command of the East attends to 7 districts, all of them making vaccination. Tokyo. Are we going to Tokyo? Wasn't there an Olympic game? So we got our athletes in a good time. They were vaccinated, and they went there. Getting to the conclusion, what was our worries? If we have a climatic calamity, we have to be ready to act. I cannot degrade our capability because the country doesn't know what's going to happen tomorrow. Not everything is built on anticipatory studies. But we have, even if you estimate and build scenarios, not every time we really know what's going to happen. Who would know what would happen? Just Bill Gates would know about that. He alerted us, beware, we're going to have a calamity. So the practical results. This year we could classify more companies as producing defense industry, and 11 more companies are going to be classified as strategy defense industry with no tributary costs. That now we have built. Our defense industry has not stopped. Now, we have more defense products. We have more companies who have built, and the result, the practical result, we have a historical record of exportations since 2019. Thank you. They asked me to stop. Control out there. And 1.5 billion was the highest mapping exportations in Brazilian history. So the strategy to face the crisis, preserving our competencies with funding efforts and maintenance efforts, training efforts, the cost of the military institutes didn't stop, and the troop is qualified for their constitutional mission because we are prepared to face diversity under peace or under war. So what do we need to do? If we don't do this, we have to shrink the image, please. We have to um, put into work the National Lab for Contention, Maximal Contention, integrate the lab network, strategic biosecurity production, heighten our capacity of our military labs. Our military labs were working also with the public ones. We're going to talk about Butantan, Oswaldo Cruz. We're working like crazy. Our labs have to be ready to work, even if it's not marketing driven. We also are working on marketing too, but we're talking about a crisis. We have to support life maintenance, the capacity to maintain life, ventilators, infusion bombs. We're vulnerable in here. If we had a public health problem regarding the kidneys, hemodialysis, we're not producing such equipment. We're not producing filters for kidney failure. And we have 150,000 people under kidney failure and hemodialysis. This is something we have to solve. We have to amplify your operational defense for chemical and bacteriological and radiological and nuclear problems. Now we have faced a defense under the World Cup, but we still have to better that. We have to start a data bank on bacterias. We know we are going to face problems regarding the usage of antibiotics. So we have to develop this bank because there are viruses that eat bacteria called bacteriophagos. I have to develop a bank of those the bacteria that eat viruses. And now we have to approve and put into motion a policy of biosecurity and bioprotection and all the chain of production. This policy with the labs and before, with that we will development on those segments and be protected to any other crisis. And with less consequences. We know the lessons, and we have to keep working. Thank you so much. I hope we don't get over. I hope we don't face another crisis like that. Sometimes people call me prolixic. Ladies and gentlemen, we'll have some minutes to answer some questions if there is. So this is a good moment if you want to ask anything. I have a question. Why You've shown me some news about the government that I didn't know, and I'm not so bad informed. But I think there's lack of information to the public, to people, to the public to know what the country is producing and doing. Oh, this is an answer that's not very simple. We know many things being done, and I highlight that currently one of our partnerships in the Ministry of Health that was well done with national labs, we start to produce growth hormone that millions of kids use and we didn't know. So there are lacks, there are gaps that have to be filled. We have PDT, that's Partnership for Productive Development. We lack, of course, to work a little more the communication issue. But that's why we are fighting towards boosting the enterprises, the companies to associate, because our channel of communications is through the associations, because it depends on media. I know it's not. I'm not criticizing, but we need that industry is connected to, and the actors are connected to the associations, because we have a intense communication. We have a web page just for defense development. We have a WhatsApp web with engineers and researchers. So the organizations have to get into that at ecosystems, and then Apex is one of our sponsors. We are stimulating so that the companies go all over the world. We have one in Egypt and one in Colombia now. We come from showing in every places. For example, we have a stand in Dubai. Another day, one of my friends that was developing ventilators was in a BIMUS fair in Antwerpia. So if I don't integrate the systems, I stay in just the unsophisticated public information. And you that are in the qualified transport industry have to get into that system of communication, because we do inform. We send releases, we send invitations to participate into events. We have public calls from the Ministry of Innovation and Technology. We have 21 projects that are financed by FINEP, but the Ministry of Science, Technology and Innovation had 8.4 billion into financing innovation. I had other billions in the industries. So if you have that innovation process, you have to understand that ecosystem. You have to be aware of what's going on at those ministries, and that's public. You have communication, but it's not a type of communication you find in everyday life sites. It's a sophisticated communication that ensues from probably from our lack of making public in a specific way of the opportunities for we in defense are also in the system in the P that allows for in any industry that wants to make a qualified lab for the Army forces. We have a share financing of that project. So if the laboratory would pay 9, now he can pay 3. So it has to do with the state ecosystem without without making any marketing for that. Because of the COVID, we knew there were 100. In Senepen, we have 1,400 people working. And so if your company wants to build any system, you can work with CNP Lab. You go there with no cost because FAPESP pays for that. the Federation for Support of Innovation of State of São Paulo. So, because if you innovate, you better the ecosystem because you pay taxes, you have resource and wealth generation. So that's triple pillar support have generated a lot. Ministry of Defense, Ministry of Agriculture. We have an intense movement. It's important you, the businessman, have to get into that ecosystem and understand what's going on. For example, the MCTI, Ministry of Industry and Innovation, has invested in. Help me, Márcio. You are younger and more intelligent. A grafeno. Well, one of the members of SINGE, Taurus, is here, is already building the pistols in graphene, the material graphene. There has been an investment of the Ministry of Science and Technology. The university in the southern part that had a startup. Among those sponsors, you have the technological part of São José dos Campos. We work along them. We work with technological UNB, Cimatec Bahia, Cimatec Santa Catarina, Cimatec Minas Gerais. The startup got connected to them to help air development. All those companies are in our São José dos Campos Technological Park. Now we have brought other governments to build partnerships. I've told you about the rare minerals. We talked about graphene. Now we're talking about vanadium. There is a enterprise, a company in Bahia producing vanadium in tons. We have a joke. Well, the startup has built an American startup, and now we can stock wind and sun. We had a battery. The advantage of vanadium, it doesn't catch fire, and it doesn't have a lifespan. And the ventilator stops, but the vanadium itself doesn't end. So you can store wind for 10 hours, and that is get delivered to the system in the form of electricity. So this is innovation that's available. So it is important, and we have that in our website. You have to get that into environment. What's the name of those innovation institute in Campinas? I cannot remember. Oh, you're weaker than me. You're a nuclear physicist. You should be more intelligent than me. Well, our time is up. Thank you so much for your presentation from the Secretariat of Defense and its products. Your presence brightened our event.
To continue our activities, ladies and gentlemen, we have the privilege of hearing Dr. Carlos Simotti. He is the President Director of Sigma Integrated Systems, and he will be with us remotely. I would like to see if the technician already has the link to Mr. Simotti. If you do, please have Mr. Simotti join us in our morning program. Our technician is informing us that our presentation will be given in English, so please, if you need a translation, you can pick up earphones and the headset and the radios at the entrance of the hall. audio, the original audio will be given to the room and translated through the translation equipment. If you need translation equipment, you can pick a pair of headsets up at the entrance of the auditorium.
Temos o link com o Dr. Simotti, diretor?
Mestre, só um instante. O palestrante está tentando conectar. E assim que ele entrar, a gente dá um sinal para você iniciar, tá bom?
Ok.
Of the group, what is called the Athens. Now I will go. I will speak about what the swarms, and before I give you a short presentation.
Olá, mais uma vez, bom dia a todos, sejam todos
Okay.
bem-vindos. Daremos sequência, então, às atividades
Good morning
desta
to
manhã.
all
Teremos o
of you.
privilégio de ouvir, neste momento,
My name
o doutor
is
Carlo
Carlo
Simotti.
Simotti,
Ele é
and I
diretor-presidente
will
da Sigma
present to
Integrated
you
Systems.
the
E ele está
a
remotamente
short
conectado a nós.
presentation
Nosso
of our
comentário, o
group.
doutor Simotti,
Sigma Consulting
doutor
is
Simotti, para nós
the
aqui, bom dia,
prime
seja muito bem-vindo.
contractor of Athenis Group, which is a
O
group
tema do Dr.
of
Simotti é
50
o AV-SWOR,
companies
pequeno
of
equipamento de
Rome
localização
Technical
precisa e
Park
identificação
in
e
the
rastreamento de radar e fontes de radiofrequência. Esse é o tema que será tratado neste momento pelo Dr. Simotti. Bem, então gostaríamos de passar já imediatamente a palavra ao Dr. Simotti. O senhor fique à vontade, estamos aqui prontos para ouvi-lo. Seja bem-vindo, o senhor tem a palavra.
If you like, I go directly to the subject. I just have 2-3 slides to present our group. So I go straight on. We are a group of 50 aerospace and defense companies. And our experience is in the electronic defense, intelligence, and flight simulator, aircraft, and the UAVs for the subject that we are going to consider. And our technologies are microwaves, antennas, and robots. For the civil sector, our experience is on the cybersecurity, smart city, satellite analysis, smart farming, with the technology such as artificial intelligence, virtual and augmented reality, IoT world. These are our international partners. And the subject of that I am going to present is the UAV swarm in the field of intelligence and countermeasure. And also some cases of success. The classes of application for UAVs that we have treated are all military certified, are a 6-ton UAV micro US, a Strix mini US with 20 kilograms of load, a Shadow 2000, a tactical US, and for countermeasure, an helicopter similar to the NG MQ-8. Let's start from the tactical UAVs and to see what are the payloads. We start with the Shadows 2000. This platform has ESM A-Lint equipment that we developed for Italian Air Force. This equipment has a full, the equipment on board has a full ESM and A-Lint systems with 4 antennas and all the equipment that we are going to see in the next slide, and is connected to the command and control system. This is the payload with the main characteristics, and this an ESM A-Lint which is used also in the avionic application with operator, with unmanned and manned platforms. This is a block diagram of the ESM equipment used in manned platforms, and is based on 4 channels, four antennas, 4 microwave channels, and 4 signal processor adapters. Another payload that we have also developed for the Italian Air Force is the communication intelligence system with 3 antenna arrays for the 3 band, A, B, and C band, and totally this equipment analyzes the communications from 50 megahertz to 6 gigahertz. This equipment, the COMINT equipment, has 3 antenna arrays for the 3 bands and the switch matrix, and is used for tactical UAV as it is. Which this is shown as a typical antenna with the real dimension, and this was done in the project, in the real project that we were developing for Italian Air Force. This is B band antennas. I go faster because this presentation can be seen for details. Okay, I can send to all people. This is the set of the antennas, which the B and C band antennas and a radome. This is a special picture on how is mounted. The antennas are mounted on the test aircraft. Let's go to swarm. Swarm of tactical UAVs is done to have 2 advantages on the single platform. One is a better localization, with immediate triangulation, and a better land coverage with mission assigned to each UAVs. Each UAVs is also an independent, as an independent payloads to detect, analyze, and identify all the radar emission in the case of ELINT, and also the communication emission in the case of COMINT equipment. The UAVs, all the UAVs are connected to a ground control station that makes the combination of the data received, and then make all the operation of command and control. The task of this UAV swarm are in the scenario either naval and terrestrial, ground, naval defense against air and surface threats, intelligence for analysis and identification of radar emitters, protection and patrol of ports and coasts with search and rescue functionalities, and counter-terrorism and illegal trafficking. And this for the naval environment. For terrestrial environment, border protection and patrol, protection of sensitive areas, intelligence, special application anti-improvised explosion devices. One of the most important characteristics of the UAV swarm is the localization of radar emitters and communication RF sources for localization from multiple, with a triangulation from multiple point of view. Now let's go to the mini UAV for electronic warfare. A typical mini UAV does not have the capability to carry a traditional equipment for alien and combat application. What we are studying now and developing a new approach to split the equipment between UAVs that cooperate strictly. We think to the strikes model, mini US with a capability of 20 kilograms. So 20 kilograms will be used in the way that follows. Thinking to the traditional ESM ALINT system, as I said before, there are 4 to 8 planar antennas, 4 receiver channels, 4 synthesizer, and then a pulse analyzer, a processing unit, communication, and remote ground station. This equipment we split in four slides for each UAVs. So each mini UAV will have 1 spiral planar antenna, 1 receiver channel, 1 synthesizer, a pulse analyzer for measurement of radar parameters, and as reduced processing unit for just an instantaneous measure of equipment, while the environmental synthesis and identification is and also localization are done in the ground station. The equipment weight is reduced to about 2 kilograms, and 4 mini UAV can cooperate strictly for ALINT and COMINT missions. This is a representation of how look the mini UAVs and how they are launched. We can note that the fact that a man with a catapult, come si dice, non so, a man from ground or from ship can launch this type of UAVs. This will extend the electronic warfare capability to many areas that are not accessible from airports, because tactical UAVs needs an airport. Mini UAVs can be launched on the site that they are needed. And these can be used again for land security and monitoring, for search and rescue and border security. Typically, with this section is used for intelligence mission and for, as we see, the territory management and the countermeasure management. So another subject is naval defense and precision on localization, not achievable with the existing multi-antenna single platform systems. But a block diagram show a picture of the 4 channels, the digitizer which are on board, and the digital signal processing plus data recording is on the ground station. The concept is to have algorithms in the ground station to integrate all the information that come from the UAVs, and then to drive the flight mission according to the scenario, to optimize the position of each UAV. So there will be as the software of the software support in the ground station, a flight manager, most important, a neural network for artificial intelligence operation, and trilateration of algorithm for the best localization. As I told before, the UAV that we are going to consider is low cost and expandable. The UAV capabilities will be configurable, are configurable in terms of frequency band, mission route, scanning rate, operation mode, and emitters library. This means that, as we will see in the following slides, that the UAVs can operate in different areas or in the same area with different frequency band or in localization mode pointing to an assigned emitter assigned from library. Each UAV has an antenna with angular coverage of about 120 degrees in the frequency range of 0 to 40 GHz. Once identified 1 hour of interest from the command and control, all the routes, there is a mission planning activities, so that either for intelligence mission, for search mission, and for radar detection, all the routes are programmed in the command and control, and to each UAV is assigned a mission route, a frequency band, and a library of mission to search. So, to resume what I said, we consider a swarm of 3 to 4 mini-class UAVs equipped with ultra miniaturized receivers. The mission are security mission, ISR, intelligence, land security and monitoring, search and rescue with high precision of localization. A small new design, I already told. Each UAV, which is a strict class from Alpi Aviation, has the following characteristic: 3 meters wingspan, 9 kilograms of weight, 2 batteries for 4 hours of autonomy, and again, the UAV is low cost and expandable. Triangulation, how the UAV are making the triangulation, and this is a typical scenario where the mini UAVs cooperate with satellites and manned platform and big UAVs. To resume the UAV swarm advantages, we are a better geographic localization, because the UAVs operates at hundreds of meters from each other. The configurabilities in terms of mission route, frequency band, geographical area, in localization model, and the individual threat assignment. Low cost and spendable, operating mission with autonomous route, without interception, and with registration of a mission intercepted for later analysis on ground. Operational mission with operator online control, slow scan for search radar, and online programmable operating modes. The mini UAVs are more stealthy and less vulnerable to enemy weapons. This is already told. Thinking to the operating frequency band, these are all the covered microwaves bands, and we operate and at a band from 0 to 40 GHz that can be divided for each UAV. This is as the consequence of each UAV working for a shorter, with better processing time and for better probability of interception in each sub-band. Each UAVs can be programmed to act in different area of land, which pre-programmed mission routes. And in the picture, there is an example of how the routes are performed. Third subject is to assign to each UAVs a threat and assigned threat, so that in this case, the UAVs search for particular radar. And once they have intercepted the threat, they can localize exactly and measure exactly the parameters. Fine analysis is performed at the ground station, where all the operator of the ground station can require to each UAVs a record of particular emission PDMs, which is pulse descriptor messages, so that the ground station can make a particular analysis to identify the signature. A localization of the transmitting emitter is done using particular algorithms like Kalman filter or Bayesian algorithms, and then to make a provision of the future trajectory. We already said area defense. The application are defense for defense of the area or attack. Attack means jamming to the radar, particular radar that are not cannot be attacked by individual platform. In this case, multiple platform can give deception with multiple false targets. This is the case of radar with step mode. In this case, the UAVs make a cooperative work, and so that they can jam in work zones particular radar with step processing. In this case, we must make the mission with tactical UAV that can carry some weight for providing the power for the countermeasure. The step radar has a technique with a two-dimensional filtering technique that can locate in time, either in space and in time, a particular target. So in this case, the the system, we can direct UAVs from different angles so that we can cause the target to see multiple false targets. Scenario we already said. The UAVs in the swarm must communicate with each other, because the reason to permit to the command and control platform to exchange the mutual asset for the optimization of the detection function, and to make all the correction due to the mutual deviation to ensure an optical flight formation, and to optimize the countermeasures activated by each individual UAV to counter the step radar. Command and control, the command and control manages the swarm in terms of reciprocal communication and scenario definition following the data measured through ESM system installed on the UAV. This means that they capture the data, receive the data, and then make the exact identification of each radar emitter. Other controls of the command and control this is already is a repetition, so that I say that the command and control station update the position and the routes of all the UAVs depending on the variation, the changes in the scenario. To manage the swarm, the command and control has several processing layers. One decision-making layer of software for task evaluation, mission planning, and task assignment to each UAVs. Then a path planning assigns subtask management and planning to the platforms. A control layer makes the coordination and the control of the formation, and the avoidance of obstacles. The communication layer provides the communication network, the information exchange from UAVs to command and control, and from command and control to UAVs, and the data fusion of data received. The application layer is characterized from industry, for agriculture, for military, and for transportation. This is so the software process. This is a typical representation of the operator console to analyze the signals received from UAVs. An example, there is an example of cooperation with multiple platforms that will be required always more in the future scenario. This is an application that we developed for Italian Air Force for cooperation between manned and unmanned aircraft for anti-improvised explosion devices, techniques for detection for underground improvised explosion device. The 5,000 feet images of land are controlled by a manned aircraft. Then a UAV, mini UAVs goes to make control of 1,000 feet altitude. And then when there is a suspect that there is an underground improvised explosion devices, a rotary wing UAV is sent to examine up to 1 meter of altitude to avoid the main intervention. Then by analyzing the terrain characteristics with special algorithms, then we can detect the presence of explosion devices. The applications are obviously in the military areas, and this is the swarm of UAVs can operate in different scenarios, in different lengths to reduce the time for investigation. This is finished, and then I finished the presentation. I thank you for attention and say thank you to everybody. Ho fatto, qui non ho sentito niente, pensi che c'è.
Muito bem, nossos agradecimentos.
Very well, our thanks to Dr. Simotti, and along the same direction we will have one more presentation. This time it will be by Dr. Mauro Piccini, the director of the same company, Sigma Integrated Systems. We have a link for Dr. Piccini.
Precisamos de alguns minutos para colocá-lo.
We need a few minutes to connect him. He will be with us soon.
Então, de que também possamos ouvi-lo nesta manhã numa fala que, ok, numa fala que dá sequência à fala anterior.
This is going to be a talk that continues the line of thought of the previous presentation. Dr. Piccini, can I greet Dr. Piccini and ask him to join our session? Very well. Excellent. Dr. Piccini, you are welcome. It is a pleasure having you.
Can we start?
Ciao.
Okay, can I start, sir? Okay, I'm talking about a naval defense system against a sea skimmer missile. Of course, I will try to talk about the most important parameter that condition the project, but analyzing them, it is possible to verify the feasibility of this kind of proposal. Let me say that a sea skimmer is in general the main threat for vessels of all types. And of course, it can be launched from in different conditions. For example, for coastal ramps, for submarines, from ships, planes, and helicopters. Typically, one classic value range from typically 0.8 up to 0.9 Mach for the traditional. In this condition, what happens is that when the missile, the monopulse radar of the missile is activated, Typically, the distance in this case is about 25-30 kilometers, and the time on which the missile reaches the target is about 20-25 seconds. Of course, if you increase the speed and to maintain the order of reaction time, of course, the distance in a certain time increase. Now, the project, the characteristic of the feasibility that we wish and we are in progress to obtain is to demonstrate with the feasibility study the capability to develop this system. We will design and validate this system, and for the novel defense system, and the technical that we use is the cross-eye. Of course, the typical sequence activity will be the identification of the following, of the fundamental characteristic that I will synthesize in 3 or 4, but I will explain you the feasibility of the system. We'll, of course, will define the subsystem technical specification and the detail including the installation, and also we will validate the system with some reduced configuration. In the figure on your right, you can see a block diagram that just illustrates some characteristics of this system. Of course, we will have a console through which will be received the data from ESM system to know the scenario, and this data will be also added to the data of time difference of arrival, and the purpose to transfer this data to one logic unit, having the purpose of defining the trajectory of the missile. This one shall allow the cross-eye platform, that now I will explain what are, the cross-eye platform to be oriented in such a way to control always the path of the missile and put it away from the ship. As a result from the block diagram that I have seen, that I showed you before, the defense system is based on multiple cross-eye platforms, and these are realized with the solid-state retro-directive patch antenna array that perform the cross-eye. And this one is driven by a logic unit that receives data from ESM and TDOA to define the trajectography. This shall allow to be in position, in condition to orient the cross-eye platform in such a way to condition the missile in follow a certain direction. Of course, this technique allows to introduce an angle deception, an angle error to the missile that will be forced to deviate from its original trajectory. What is important is that what happens is then when the missile is deviated, one of the two antennas that realize this activity of the cross-eye could be not more illuminated. In this case, what could happen is that the missile, with that the system could realize the break lock. And this is dangerous, because if we realize a break lock on the missile, what happens is the missile could have time to reacquire the target, but after that, our system will have no more time to identify again the missile and then the relevant trajectory to orient the antenna. This is the base of this kind of technique. We call this retrodirective antenna. And you can see from this this diagram that each signal, here we have two antennas, each signal coming from one antenna and going on the other one through circulator and then amplified and vice versa, will be transmitted in the same direction of the arrival, both if it's coming from the up, down, or right. And it is important to notate that in this case, the system does not require the identification of the radio frequency of the signal, because signal pulse by pulse are processed as they are captured by one antenna. This is the typical configuration that could be realized. In such a way, you can see we will have a different patch antenna from one side and the other side, the right on the left. And one receiving antenna is connected to the transmitting one and vice versa. Of course, one block is deviating in phase of 180 degrees. This consents to obtain the transmission in opposition of a phase, but not exactly in the same amplitude, because one will be controlled in such a way that should be less with respect to the other of 1 dB or no more than 2 dB. Of course, the characteristic of this kind of configuration allow to maintain under control the skimmer missile. As I said before, this antenna should be lighted, illuminated always, and when one loses the illumination because deviation of the missile, the next cross-side base antenna will take in under control the missile in such a way the missile will be deviated. Oh. Of course, we can have a different platform or different size. The system is modular. What is different according to the size of platform and the number of a platform. So according to the size of the ship, we can have from 2 up to 4, no more than 5 platforms. An important thing is, an important thing is to have a look at this cross-side base. The difference between the distance between the two linear array J1 and J2, and now we enter in the parameter, and this is an important thing I anticipated at the end, at the start of the presentation, is that the pulse of the missile can be very short. Short means up to 0.2 microsecond. So it is important to take in consideration the length between the two linear arrays, because if you do this distance so much, so you will lose the information coming from receiving to transmitting. So the distance between these two linear arrays should be in such a way that should be not to the originated delay not more than 50 nanoseconds. Ritorno avanti. Okay. Of course, when we do the trajectography has the purpose to control the antenna in such a way to optimize the orientation according to the provenance of the missile in such a way to deviate opportunely because this cross-site platform can rotate in the vertical axis and can have a protuberance in such a way to anticipate the pulse before the echo. Another important consideration is the radar cross-section. It must be considered that now many new modern ships have the bulkhead inclinated as a purpose to try to the divergence to deviate the echo signal. Of course, this should be very good in case of the optimal divergence in such a way that no more signal can be received by the monopaths. But unfortunately, this is not true. And what happened is that considering that some echo are in any case captured by monopulse this side, it is important to consider that then when the missile is approaching the ship, then and the pulse is short, like 0.2 microsecond, of course the range gate is shorter, is very short. And the echo that enter in the range gate is not so big like someone suppose, but is reduced. And this is a phenomenon that optimizes the jammer on signal report generated by the system. Of course, the patch antenna must be in a certain number to have enough power to control the missile. One of the novelty of this kind of activity we are in development is to in certain way use some new technique, new advanced technology to realize some component, in particular solid state amplifier. Of course, we will need some, to do this, some gallium nitride to realize a solid state amplifier. And the reason is that this kind of solid state amplifier realized with this technique have again flat as much as possible on the O band. Another consideration is that, of course, this kind of a system have a certain band, and to have a patch antenna in large band, this includes to produce different system integrated, and then this is also a particular technique that must be considered and realized. So the challenge, we can conclude that the challenge of this kind of activity is this kind of ultra-wideband patch antenna, phase shifter and amplifier stage for the diversity of the threat. The use of gallium nitride for solid state. And another important thing is to consider the matching and the calibration between the all component of each platform antenna. With this kind of a project, the final activity will include the identification of the fundamental characteristic of the proposed system and the subsystem technical specification definition, the detailed design of the system, and the validation of a reduced prototype system. If you have any question, I am ready. Thank you, I have finished.
Muito bem, nossos agradecimentos
Very well. Our thanks to Dr. Pettini and Dr. Simotti, who brought to us a very special presentation closing this morning's works. Our many thanks to the participation of both of you, and you have granted our event. Many thanks. Now we will take a break for lunch, and we would like to thank all of those who have followed us here in the auditorium and virtually, remotely. So we will take our leave and resume at 1:30 precisely. Enjoy your lunch. Afternoon. Welcome to the CSTM. We're resuming our activities. This morning was very busy. We had interesting debates and discussions of the presentations given in the morning. And this afternoon, we invite to give his presentation Lieutenant Colonel of Infantry Leonardo Gomes Saraiva. From the strategic program of the Army for obtention and for operational capacity training. He is going to give us the past, present, and future about the system on remotely piloted Air Force technology, aircraft systems.
Muito obrigado. Boa tarde
Thank
a
you.
todos. É uma satisfação muito grata.
Good afternoon. I am very
nesse
pleased to be
importante evento,
here with you in this important
para a
event.
base industrial
It is
de
important
defesa,
for the
importante
basis
para a
of the
defesa nacional.
defense
Trago
industry
também
and the
aqui
national defense.
este importante tema
I am
que tem
here to
ganhado
talk to you about this
importância ainda
important
mais,
theme that has become
dentro das
increasingly
Forças
relevant
Armadas,
within the armed
dentro do
forces,
Exército, notadamente,
within the army
e
especially,
no âmbito ainda
and
do Ministério
in
da
the scope of
Defesa,
the Ministry of
que é o
Defense,
sistema de
which is
aeronave
the
remotamente pilotado.
remotely
E eu vou passar,
piloted
como já foi
aircraft
apresentado,
system.
o passado,
And I'm going to
o
tell you
presente
about
e o
the
futuro
background, the
desse
current status,
sistema de
and the
material de
future
emprego
of the
militar.
employment of this militarily used equipment.
Bom, apresento então
I would like to show you
objetivos para
our
a gente
purposes,
apresentar nesse bate-papo durante esses 45
the purpose
minutos.
of the
O
presentation I will
objetivo
give to you in
de
the next
apresentar
45 minutes.
a
The
evolução
main objective is to
desses
present the evolution
sistemas no mundo.
of the SARP
A gente
system
vai
all over the
falar
world,
de
and we're
maneira
going
bem
to discuss
breve,
this briefly.
apresentar a evolução desses sistemas
And the
dentro
evolution
do
of this
Exército
system
brasileiro e apresentar
in
as
the Brazilian
tendências
Army,
e
and
expectativas
to show you
futuras da
the
evolução
current
desse
and
sistema
future
de material
trends
de
and
emprego militar
expectations about the
no
evolution
mundo
of the
e
SARP
no
system in the world and in the Brazilian Army.
Bom, como roteiro, para a gente atingir esse objetivo, vou
For us to
passar
reach this
brevemente
objective,
sobre uma introdução.
I'm going to
Vamos
give you an
falar aí sobre
introduction.
o histórico
We'll
mundial,
talk about the
histórico
global
dentro do
background,
Exército, e vamos
the
falar sobre alguns
background in
aspectos
the
gerais
Brazilian Army, and the
relacionados ao
general
processo
aspects
de
related to the
obtenção desse
process
material dentro do Exército
of
brasileiro. Vamos
acquiring
falar
this
rapidamente sobre a
material for the
situação atual,
Brazilian Army. We're going to talk about the current situation,
especificando os modelos, alguns requisitos e de cada categoria.
specifying
E vamos falar
models,
também
requirements,
do nosso subprograma
and
SARP, que está dentro do
per
programa
category
OCOP.
requirements and the subprogram
Vamos
SARP.
passar também os desafios,
We're also going
tendências e
to
perspectivas
talk about the
futuras e uma
challenges
breve
and the
conclusão.
expectations for the future, and the brief conclusion.
Coloquei essa imagem
I
já
chose
como
this
no
image
processo introdutório do tema,
to begin
e
our
essa
discussion.
imagem, para todos aqueles
And
que a
this image,
observam,
for all of those
eu
watching
acredito
it,
que
I believe
vem pensamento
it
na
brings
cabeça, né?
you, it makes you think
Alguém
of
poderia
something.
Já fazendo uma interação com a plateia.
Now, interacting with the audience, could I ask you, may I ask you, what comes to mind when you look at this image? Would anyone like to say anything?
Enfim,
Well,
o que eu quis
what
colocar
I
aqui
wanted
realmente
to
a
say
questão da
here is,
imensidão de
I wanted to
opções,
show you the
imensidão de capacidades,
number of
imensidão de necessidades
options,
que esse material
needs, and
tem
capacities
atendido
this
de
material has
maneira
met
dual,
in a
tanto no
dual
meio
manner
civil como
in
no
the
meio
civilian
militar. E a gente
scope and the
precisa
military. And we
organizar,
need to organize,
sistematizar
systematize
nosso pensamento,
our
nosso
thoughts,
planejamento,
our
para
planning,
que a gente
so
consiga
that we
ser
can
eficiente.
be efficient.
Desta forma, a gente tem que começar
So we must begin
conceituando, não tem jeito.
by establishing
Então, a primeira
concepts.
confusão que existe
So the first
sobre esse
misconception
tema
about
é
this
em
theme
relação
is
ao conceito
about the concept
RPA,
involves the
RPAS,
concept of
UAV,
RPA,
UAS, VANT,
AirPass,
drone,
UAV, UAS, VANT,
todos
drone.
têm um nome,
All of them
seja ele numa
have a
sigla em
name
inglês,
in an English
espanhola,
acronym or a
português.
Spanish
Então, há
acronym,
diversos
Portuguese.
nomes e a gente vai entender
There are
que
many
tudo, na
names, and we must
verdade,
understand that, in
se
fact,
trata
they are all
da mesma
the
coisa.
same thing.
Todas essas
Those,
siglas, todos
all
estes
these
nomes,
acronyms,
quando
all
são
those names,
pronunciados,
when they
eles
are pronounced,
remontam
they
a sistema
are
de uma
referring
maneira
to a
mais simples
system
ou complexa.
of a more
Todos
complex
eles
or more simple
têm a presença,
nature.
a
All of
ausência, na
them
verdade, de piloto na cabine.
lack pilots. They are all unmanned.
Somente
And
o termo VANT que
just the term
remete
VANT
à questão da autonomia. Porém, nos
refers to
dias
autonomy,
atuais,
but
ainda não
currently
temos nenhuma aeronave
we do not have
completamente autônoma. Ou
aircrafts,
seja,
any kind of aircraft that is
todas são, no
completely
mínimo, em
autonomous.
algum
So they are
momento,
all, at some
remotamente
point, remotely
pilotadas.
piloted.
O drone
The drone
é o conceito
is
original.
the original
A gente
concept.
vai ver o início,
We're
quando
going to
começou a
see,
usar
to
esse
look at the
conceito
beginning
drone,
of the use of
que
this
remete
concept
na sua
that
etimologia
refers in its
à abelha,
etymology, refers to bees.
é o conceito inicial,
This is the
e
first
depois
concept,
surgiram os
and
outros
then other
conceitos,
concepts
porém, ele ainda é muito mais
arose,
utilizado.
but the
Alguns
original
usam,
concept is the most
acham
used.
que quando
Something
fala
that
drone,
some people think
utilizam esse
when we talk
conceito para
about
os
drone, we're
pequenos
talking
drones.
about the same concept that
Outros
is used
acham
for the smaller
quando
drones.
pronunciam
And
drone, estão se
others think
referindo
that when they say drone, they mean
aos sistemas
the
militares.
military
No
systems.
entanto, todos
However,
são praticamente
they are all
o mesmo conceito
the same
e
concept,
remete
and they all
ao
refer
subsistema
to
SARP, ao
the
SARP,
SARP
porque todos
subsystems,
eles, mesmo os
because all of
pequenos,
them, even the
enquanto os
small
grandes,
ones
eles são
and the
compostos
large ones, they
por
are all
subsistemas.
formed by
O
subsystems.
primeiro
The
subsistema,
first
e que é o
subsystem,
mais
which is the
visualizado,
most
é
widely
o
known,
subsistema
is the
que
subsystem
compõe-se
that
das
is
aeronaves
formed
do
by
meio que voa.
aircrafts.
Depois a gente pode
Then
elencar
we
a carga
can
paga ou os payloads.
mention the
E ali
payloads,
pode ser eletroóticos,
which
radares,
can be
armamento,
electro-optic,
material de guerra
radars,
eletrônica, cibernética,
weapons, electronic weapons,
materiais
cyber weapons,
anti-SARP,
anti-SARP
jammers,
materials, jammers,
dentre outros.
and others.
Outro subsistema desse
The other
grande
subsystem
sistema
of this
SARP
larger
são os
SARP
terminais de
system
transmissão de dados,
are the
os
data
containers,
transmission
as estações
terminals,
de
the
controle de
containers,
solo
the
e as estações de
land
transmissão de dados
control
também,
stations, and the
os
stations for
terminais de enlace
data
de dados
transmission,
e a
the
infraestrutura de
terminals
apoio.
where
Então,
data
esses
is
são
interlinked,
os
and the
componentes
support
básicos
stations. Those
do
are the
sistema.
basic
Eu
components
chamei aqui
of the
de
system that I
subsistemas
have
porque,
called here
inclusive, nessa
subsystems,
figura eles
because
estão
in this
estão
here in
separados.
this image they
Tudo
are
isso
separate. All
visa
of this
proporcionar
aims
que eles operem num cenário em que a
to
gente
enable them
observa
to
a
operate in the
execução de uma imagem,
scenarios
a
that we
execução
observe.
de
The
tiro,
execution
muito
of an
comum hoje a gente
image
observar
or
isso na
shooting a
internet.
target. We see this a lot on the
Então,
internet today.
aqui é cenário
So this is a
completo
complete
de uma
scenario
operação
of an operation
desse sistema
of this system
de aeronave remotamente
of
pilotada.
remotely
Obviamente,
piloted aircrafts.
quando os sistemas
Obviously,
são maiores,
when the systems are
eles
larger,
exigem uma
they
logística
demand
maior,
larger or
maiores
more complex,
potências,
more powerful
então
logistics and more
a
power.
gente
So
observa
we can
melhor
observe,
os
we can see
equipamentos
the
que compõem
equipment
esse
that
subsistema.
forms
Os
this
menores,
subsystem,
geralmente a
the
gente
smaller ones.
tem o hábito de não
Obviously,
chamar
we
de
do not call
sistema,
them normally,
mas
we don't
ele
call them
também é um
systems, but
sistema,
they are
só que de
systems
forma
too. But they are
miniaturizada. A
miniatures.
parte do controle, podendo
The
ser controle à
control
parte
could
ou
be
até mesmo por meio de
separate,
celular,
or it could be done through
como
a cell
é
phone,
muito comum
as
com os
is commonly
pequenos SARPs
as
de
commonly
hoje.
happens with
Mas, de
today's
certa
smaller
forma,
SARCs.
todos eles
But they all, up to a
executam
certain extent, they all
essa
execute
operação
this operation
com a formação nesses
with
subsistemas.
formation of this subsystem. In the Brazilian Army, we have adopted the concept of SARP, System of Remotely Piloted Aircrafts, for the small ones and for the large SARPs. In the Brazilian Army, there is an inclination for that, for the larger systems to have more aircrafts in the composition of the system, so there might be one or more aircrafts, but all form a system. And in the larger systems, there is also an inclination for those systems not to end when the image reaches the operator of the payload of that aircraft. The system continues to send what we call a terminal for data transmission. We could call the rear.
Daí a gente passa para entender melhor
we can understand this system
e como ele está evoluindo,
and how it is evolving. To understand this, we need to understand it along this line of thought, or we need to study history for us to be able to project the future. So in 1783, historically, we could say this is the beginning in France of the first part of the evolution of the SARP in the global context, where the first public demonstration was realized of an unmanned aircraft. In 1949 in Austria, we could say the first military use took place of a system. I'm saying SARP here, but obviously at the time the system was not complete, as we have shown here. We could understand that we're talking about unmanned aircraft, where a bomb was projected, a balloon bomb was projected in France in 1858. There was the first aerial photograph in 1896 in Sweden. Then the first camera was mounted on an unmanned aircraft, and in 1858 in the US, Tesla demonstrated the first ship controlled by radio.
In 1915 também,
in 1915,
no Reino Unido,
in the UK,
foi utilizado então fotografias aéreas
aerial photos were used as
reconhecimento de
an acknowledgement of strength of the forces in combat at the time. This is an achievement when photographs were taken for military recognition of territory. This is a typical mission of a SARP today. In 1917, also in the US, the first torpedo SARP was designed, which would stop, the engine would stop at a certain distance, the wings would drop, and the device would fall onto a target with explosives. In 1935, in the UK, the TH-82B Queen Bee aircraft, this already refers to bees, so this was the first one, an element controlled by radio for the practice of air shooting. This device was a low-cost one. In 1936, in the USA, an admiral who visited the UK observed this device, this low-cost device controlled by radio, and he started a project, the SARP program, within the U.S. Navy in the U.S. So in 1937, the first torpedo SARP controlled by radio was developed by the U.S. Navy.
Aqui em
Here
1941,
in
então, o primeiro
1941,
SARP
the first SARP,
alvo controlado por rádio foi desenvolvido nos Estados Unidos.
a
Então, era
radio-controlled
equipamento que
target, was
voava
developed in the
via
US. It
rádio
was an equipment
e
that
que
could fly. It was
proporcionava o
operated by
treinamento
radio, and
dos
it
pilotos de
provided the
caça,
training for
simulando, então,
the
de forma mais
um,
real
for
os ataques e as
pilots,
manobras
air
de
pilots,
combate.
to simulate maneuvers,
Em
attack and
1943,
combat maneuvers.
foi
In
inventado um
1943,
bombardeiro semi-tripulado em que o piloto
a semi-manned
abandonava a aeronave ao avistar o alvo.
aircraft
Logicamente,
was
isso
created
não
where the
obteve
pilot would
muito
abandon
sucesso,
the
não durou
aircraft
muito
when
tempo, pela
he or
conta das
she
implicações que
saw the target.
esse
This didn't
sistema
last for long, of
gerava.
course, because of the
E em
complications of the implications
1945,
of
na
this
Alemanha,
device. In
uma bomba voadora
1949, in
V1,
Germany, a
muito,
flying bomb, the
muito
V1,
interessante também essa
very
bomba
interesting
voadora,
also this flying
porque era
bomb, because it
objeto
is an object
que lançava-se e não
that
se
was
tinha muito
launched, and
interesse,
there was
não se
not
podia
much interest.
controlar
It
ela
could
durante o
not be
voo,
controlled
porém,
during flight,
fazia-se os cálculos
but
de
calculations were
autonomia
done
de
on the
combustível dessa bomba.
autonomy, the
Em
fuel autonomy
determinado momento,
of this bomb, and at a
acabava-se o
certain moment
combustível e
the
era cair.
fuel
Então, não era possível
ended
controlar
and it dropped, it
exatamente
fell.
o
So it was
local
not
onde ela
possible to
cairia.
control the precise place where it would fall.
Em 1973, e aí
In
Israel, já o
1973,
primeiro
in
SARP
Israel,
desenvolvido já
the
para
first SARP was
reconhecimento e
developed for
vigilância. E aí a gente já
recognition
começa
and
a ver
vigilance, and this is
realmente
where we start to
sistema
see
se aproximando
the
daquilo que a
system
gente
already approaching what
apresentou
we
inicialmente.
mentioned
Em
initially today. In
1982,
1982, in Israel,
foi então realizado o emprego de SARP
the
contra a
SARPs were
Força
employed
Aérea
against
Síria.
the Syrian Air
Então
Force.
foi uma primeira batalha que o SARP
It was the first
fizeram a
battle
diferença
where
no
SARPs made a
resultado
difference in the
daquele
result
combate.
of the combat.
Em 85,
In 1985,
os Estados Unidos aumenta a sua
the US
produção de
increased
SARP
its production of SARPs.
e em 86
In
ele
1986,
assina acordos de
the
desenvolvimento
US signed
conjunto
agreements
de
for
SARP
joint
entre
development of SARPs
Israel e Estados
between the
Unidos,
US,
elaborando ali
US and
o
Israel,
projeto conceitual
creating the
e
conceptual
que
project
denominou-se
that was
posteriormente de Pioneer.
posteriorly called Pylon.
Em 91,
In
tivemos a Guerra do Golfo,
1991,
com os SARP sendo
there was the
empregados
Gulf War.
de forma
SARPs were
contínua.
employed continuously,
Então já uma nova missão de
so there was a
vigilância
new
em
vigilance
todos
mission
os dias do combate. Em 96,
performed in every single
foi
day of the
desenvolvido o
combat. In
Predator
1986, the
nos
Predator
Estados
was
Unidos,
developed in the US.
caça,
It
SARP
was
de ataque
an attack
já bem consagrado
SARP,
no
which
meio
is now very
militar
well
civil.
known in the
Em
military and
2001, a gente não
civilian
pode deixar de destacar o 11 de
universes,
setembro,
and
que também
there was
marca ali
9/11, which we
evento
must
que vai
highlight,
impactar
an event that
diretamente
impacted
como esses
directly
meios serão empregados
the
e
manner
a
in which
quantidade,
those
forma,
devices would be
tudo o que
employed, the
aconteceu
amount and the
posteriormente até
form, and
onde
everything
nós
that
chegamos nos dias
happened
de hoje.
to date.
Em 2006, então,
In
o
2006,
SARP também ele começa a
SARP
executar
also
voos em
started
proveito da
carrying out
população
flights to
civil,
support
e ali no
civilian
furacão
population, and
Katrina, realizou
during
voos
the
em
event of the
ambiente,
Katrina,
espaço aéreo civil, em
the
proveito, então,
hurricane,
daquelas vítimas,
the
por meio de
SARPs
suas
would
câmeras termais,
support
foi
victims through
possível
thermal
encontrar
cameras.
e identificar
It was possible to
as
identify
pessoas
and
em meio aos
locate
destroços do
people
furacão.
amongst the fragments
Em
of the
2010, na França,
the
então,
remains of the city
a
amongst
gente vê uma
the
grande
destroyed
evolução
areas.
tecnológica.
And
O Parrot controla
here
o primeiro
you can
SARP por
see
meio de
the
smartphone.
technological evolution. Parrot controls SARP
Na
through a
China,
smartphone. In
foram
China,
lançados os DJIs
DJIs
e
were
aquela
launched,
série
and that series
Phantom,
called Phantom,
a série de SARPs Phantom.
SARPs called
Em
Phantom.
2013,
In
grandes
2013,
empresas iniciam
large
estudos
companies
de
started the
entregas
study
com SARP, já
of deliveries through
utilizando-os,
SARPs,
pensando em
using
utilizá-los como
already
logística.
those
Em
equipments as
2014,
for
uma rápida
logistics
expansão.
purposes. In
Algumas coisas
2012
aconteceram
is
aí
as a
nesse
quick
período,
expansion.
importantes,
Many things happened in
significativas,
this period. Many
culminando
important
ali
things
em
happened
2020,
that culminated in
recentemente,
2020, recently,
a guerra entre
in the war
Azerbaijão e Armênia,
between Azerbaijan
onde
and
houve
Armenia,
confronto
where there
entre
was a
esses dois
confrontation
países,
between those two
que
countries,
a guerra entre os SARPs
where the
foi
war,
decisiva
where the
para o
SARPs were
desfecho
decisive
desse
for
combate,
the
tendo
results
o
of this
Azerbaijão
combat, where
saído-se com
Azerbaijan
êxito
became
tendo
victorious
utilizado ele
using
tanto SARP
SARPs
armado
armed
e
in
o que
armed
ficou
form
conhecido como
and
kamikaze,
the
SARP
kamikaze
kamikaze,
SARPs as they
e,
became
além
known,
disso, outro SARP que a gente
besides another
tem
kind of
chamado
SARP
dentro
we
do
are
Exército
calling
Brasileiro
within the
de
Brazilian
munição
Army
vagante.
the random flying ammunition.
Já no EB, a nossa história de
And
desenvolvimento de SARP
UAB,
ela é
the
mais
history of
recente,
development
porém não
in the
tão
Brazilian
recente
Army,
assim. Já em
the history of development
78
of SARP is
já se
recent, but not
visualizava o
so
emprego de
recent.
SARP em apoio
In
à artilharia busca de
1978, we
alvos.
already considered SARP as a weapon for the
Em
support of
1990
artillery.
são
In
publicadas condicionantes
1990,
operacionais.
operational conditions
Em
were published.
2004, um
In
importante projeto no
2004, an
âmbito do
important
Ministério da
project in the scope of
Defesa,
the
ele
Ministry of
coordena o
Defense
desenvolvimento desses
that
sistemas,
coordinated the
uma
development of those
coordenação
systems,
entre
a
as três
coordination
forças,
between the three
utilizando
forces
os três
using the
sistemas de
three
tecnologia dessas
technological systems
forças.
of those three
E
forces was created.
para nós ali
And
tem
for us,
legado
here,
de
this is a
desenvolvimento
legacy
do
of the development
VT-15,
of the
que trouxe para nós
VT-15
aí
that brought to
uma
us
independência tecnológica no
technological
tocante ao
independence
desenvolvimento do sistema de navegação
concerning the
e
navigation
controle,
and
o
control
link de
systems,
telecomando,
links for
telemetria
telecommand,
e a estação
telemetrics,
de controle
and
de solo.
the land control station.
Realizamos então o primeiro
We
seminário em
then carried out the
2007.
first seminar in
Atualizamos a
2007. We
CONDOP agora não
updated the
mais
CONDOP.
pensando somente na
More,
artilharia.
it
Em
is no
2009
longer
já
an
uma
extension of
família de
artillery. Now we
SARPs.
have a family of SARPs.
Realizamos então a experimentação doutrinária
And then we
em
started
2010, já
doctrinary
utilizando aquele SARP VT-15.
experimentation using SARP
É
2015.
realizada então
We
uma
did
nota de coordenação doutrinária,
a
que
doctrinary
depois ela é
note of
base
coordination
para
was
o
issued,
manual
which
de
became the
vetores
basis
aéreos.
for
O
a
COTE
manual
inicia
with
a obtenção
guidelines
do SARP,
for
o
the
Horus
control of
FT-100.
SARPs.
Em
In
2014 é feita a
2014,
atualização de toda
an
essa
update was
documentação
done of all
e
those
dos
documents
requisitos técnicos
and
e
technical
ocorre
requirements,
também no âmbito do Estado-Maior do
which
Exército uma
happened
diretriz
also
de
in the Chief of Staff of the Army. Strategy
realizada
of
mais uma
purchase
experimentação
began.
doutrinária no
Another
âmbito do
doctrinary
CNO, já
experimentation
com o Horus
started in the scope
FT-100.
of the CMO.
Em 2018 são
In
elaboradas as normas
2018,
operacionais de
operational
emprego desses
norms were
sistemas no âmbito do
elaborated for
Exército.
the operation of
Em
those systems by the Army.
2019,
In
as normas para
2019,
a logística,
the logistics
atualizada
norms were
novamente a
updated.
CONDOP, já em
CONDOP was
2019,
updated in
que são
2019,
condicionantes
which are
operacionais.
operational
Em
conditions.
2020, o M
And in
expede uma
2020,
diretriz de iniciação do
the
projeto
EME
SARP dentro
launched
no
the
chapéu,
guidelines for
vamos dizer
initiation of
assim,
the
do
SARP
programa
project
OCOP,
at the
Programa
peak of the
Estratégico
COP program,
Obtenção da Capacidade Operacional Plena,
CONDOP
que
program for
está
the strategic
no contexto
program
também
for
ali
operation that
pendurado na
is
quarta
also
subchefia do
there
Estado-Maior
in
do
the
Exército.
4th Sub-Chief Office of the
Daí
Chief
a
of
gente
Staff
passa,
of the Army.
então,
And now
de maneira geral, para a gente
we
poder entender o processo
can
de
understand the
obtenção desses
process
materiais de
through
emprego
which
militar,
those materials of
fazendo aqui
military
uma
use
analogia
were
entre os
employed.
documentos
We can
civis
establish an
e os
analogy between
documentos militares.
civilian
Os
use and
requisitos
military
civis
documents. The
de alto
civilian
nível são denominados
requirements, high-level
CONOPs,
requirements, are
conceito
called
de
CONOBs,
operações. Isso é muito
operation
importante,
concepts, and this is very
como eu
important,
mostrei aquele
as
cenário,
I
para
showed
entender
you
em que
here in this
cenário aquilo
scenario,
vai
so
ser
you can
utilizado.
understand
A gente
where
chama de
those
COMOP,
devices will be
mas
used. We
é o
call them
mesmo
COMOP,
documento,
but it's
tem a
call it
mesma
COMOP,
finalidade. São
but it's the
requisitos
same
de alto nível
document with
que
the same
compreende as
purpose.
operações.
They are
A
high-level
COMOP
documents
e a
that
CONDOP, as
comprehend
condicionantes
certain
operacionais, são documentos de
documents.
acesso
Those
restrito.
are
O
restricted
que os
access
senhores podem
documents,
ter acesso são os
classified documents.
requisitos
You can have
operacionais,
access to the
os requisitos
requirements,
técnicos,
technical,
logísticos e
logistics,
industriais,
and industrial
é de
requirements
conhecimento
that
público quando a
are
gente
of
lança
public
uma licitação por
domain
meio de
when
termo de
we
referência
issue a
e
public call through a term of
podem ser
reference, and
chamados e
then
conhecidos
these,
aqui como
these
requisitos do
documents can be
sistema.
known as
Então,
support to the requirements of the
processo de
system. So
obtenção, a gente
for
tem
the
os documentos
process
de
of
ciclo de
procurement, we
vida,
have the
a IG
documents on
01018,
lifespan,
e temos
IGIA
os documentos
01
de
and
programa e
018,
projeto,
IG
isso tem que
01 and
estar
018, there are the
alinhado
documents that must be
e a gente pode
aligned,
obter por meio
and
de
we can
processo de
see
aquisição
through a
ou
procurement
processo
process
de desenvolvimento.
or development
Aquisição
process, we can have access to
geralmente
those
realizada
documents.
pelo comando
Procurement is
logístico
realized
e
by
o
the Logistics
desenvolvimento pelo
Command and
departamento de
development by the
ciência e
Department of
tecnologia.
Science and
Então é
Technology.
importante
So it is
entender
important
esse
to
aspecto
understand
para
this aspect
atentar aqueles que
to
quiserem,
attempt
aquelas empresas que
those
quiserem
companies who
participar
are
desses
interested
processos
in
licitatórios deverão
participating in the
buscar
public
nesses dois
biddings
sítios do COLOG e do DCT
can
esses
participate. They can
processos de
join and check
licitação
those
que são públicos.
procurement processes which are public.
Bom, voltando aí então,
So
vamos
going
passar
back
agora
to
para a situação atual
the
do
subject, let's talk
nosso
about the current
então
status
projeto e
of
agora se
our
tornando subprograma
former
SARP
project and now
dentro do
current
Programa Estratégico
SARP
FOP.
project within our strategic program.
Nessa situação atual, a
In the
gente
current
entende
situation, we
que nós
understand
deveremos atender
that we will
a
have to
essas
meet
as
the
necessidades do
needs of
Exército.
the
Para
Army,
isso, a gente
and for
vai
this
cumprir
we
algumas
will
missões que estão
accomplish a few missions
elencadas aqui,
linked
não
here,
se restringindo a estas.
ranked here, and
Essa é
not
só
being
uma
being
ilustração.
restricted to those. This is just an illustration.
A gente imagina que ele vai
We
cumprir
suppose
as tarefas de
that
IVA,
the EVA
busca e
tasks will be
processamento e análise
accomplished,
de alvos, aquela missão
search and
original
processing
de
and analysis of
1988,
targets,
guerra
which
eletrônica,
started in
apoio
1988,
de
electronic
fogo.
war,
O SARP
support
tem
of
condições de
fire
realizar comando e
shooting.
controle,
SARC can realize command and
logística,
control, logistics.
atuar em proveito do
It
sistema de
can act
engenharia de
in the
construção,
benefit of
apoiar a
engineering and
população,
construction
como nós vimos
projects,
ali
support the
no
population as we
Katrina,
saw as happened during
e aos
Katrina,
governos
and
federal,
to
estaduais e
help the federal,
municipais em
municipal,
ações de
and
defesa
state governments
civil.
in
Então ele pode atuar em proveito de ações de guerra e de
civilian
não guerra,
actions
operações
of war or
integradas
non-war,
interagências e sob a égide de organismos
operating with
internacionais.
agencies and under the supervision of international
Então, para isso,
organizations.
nessa situação
In
atual,
this current scenario,
nós elaboramos em
we
2021
designed in 2021
uma diretriz
a
de
guideline, a
implantação
set
do
of guidelines for the
subprograma SARP.
implementation of
Houve
the
uma
SARC
transformação
program.
de
There was a
projeto
transformation
para
of the project into
subprograma.
a
Nessa
sub-program,
diretriz, que
and
deverá
this
ser
guideline,
publicada em breve,
this
a previsão
set
é que
of
seja
guidelines to be
publicada ao
published
longo do ano de 2022,
along
ela
2022
está
is
previsto a divisão desse subprograma em 5
foresees the
fases, de
subdivision of this
2022
program into
até
5 stages from
2039.
2022 to
Ou seja, a gente consegue
2039.
fazer
That is,
planejamentos
we
de
can
curto, de
plan
médio
in the
e de
long,
longo
mid,
prazos.
and short terms.
Os projetos atuais que vão
The
ser
current
lançados
projects to be
já
launched
com o lançamento dessa
with
nessa
the
minuta nessa
launching
diretriz de
of
implantação
the
são
guidelines for
SARPs de
implementation
categoria 0,
are
1
zero
e 2.
category,
No
0,
curto e médio
1, and 2
prazo,
category
já
SARPs. In the
estamos
short and
estudando o
mid-term,
SARP armado
we are studying
e
the
a
armed
munição
SARPs
vagante
and
num
the
aspecto
remote
já prospectivo,
destination
prospectando já
ammunition
de longo
to
prazo, a gente pode incorporar aí outros
to
payloads.
be used in the long
O
term with
enxame
other
de
payloads.
SARP também está bastante conhecido e
These programs are
muda
becoming well known,
bastante
and this
a
changes the
concepção do
conception
combate.
of
O
combat.
SARP
SARPs,
anti-SARP
anti-SARPs,
e o SARP de logística.
and the logistic SARPs.
O subprograma ele tem
The
algumas
subprogram
premissas nas quais a gente
follows
pode elencar
some
aqui
assumptions,
a duas mais
some
importantes.
principles that we can
Obtenção de
list.
capacidades
Well,
por
first
módulos.
is the
Então, até
reaching
pra
of
gente
capacities through
simplificar aquela
modules.
figura inicial que a
So
gente
to
mostrou,
simplify that
pra
initial
gente
figure
entender melhor
we showed you, we
quais
can
são as
understand
capacidades
better
que ele
what
vai
are the
entender. É
capacities,
importante que a gente faça aquisição
needed
por
capacities,
módulos
and it's important
antes
for us
de
to purchase per
distribuir o
module
material
before we distribute
em pequenas
materials
quantidades.
in
Está em estudo
small
também essa
amounts. This is
centralização
also in
de
study,
meios
this
e de
decentralization of
capacidades,
means and capacity,
aproveitando melhor
and this
esse
is for
benefício
the better
de
use
centralizar os
of the
meios em
benefit of
todos os
centralization of
aspectos
means
que a gente chama
in
do
every
acrônimo do
aspect
AMEP,
of
tanto
which
da
we call
doutrina, da
the
organização,
AMEP, the doctrine of the
adestramento,
organization,
material,
training,
pessoal,
material,
educação e da
personnel,
infraestrutura,
education, and
reduzindo os
infrastructure,
custos
reducing costs,
e alavancando
and
a
leveraging
eficiência
the efficiency
do sistema de material
of
de emprego
the
militar.
system of materials for military use.
Então, dentro do programa SARP, nós,
Within
como
the
eu falei,
SARP
temos o
program,
SARP
as I
categoria
mentioned, we
0,
have SARP
que é um
0,
SARP.
which
Nós temos
is,
o SARP não man,
there
que
is
a gente
SARP
chama, o que a
no
gente
man,
adquire
the
no
one
comércio.
we
Ele
call,
também
we
hoje,
buy,
devido ao avanço tecnológico, eles
we
atendem
can buy commercially.
parcialmente
They meet
a
due
algumas das nossas
they
necessidades,
meet some of our
devido a
needs
baixo
due
custo, eles
to
também
their low
podem ser
cost
usados, já são
and
utilizados
availability.
no âmbito do
They
Exército
can be
Brasileiro.
used in the scope of the
Há
Brazilian
uma
Army.
possibilidade
There is a
dessas
possibility of
aquisições
these
passarem a serem
acquisitions being
centralizadas, elas são
centralized. They may become
descentralizadas. Estamos
centralized,
então
and
aguardando
we are now
para
waiting
publicar
to
a diretriz
publish
de
the
implantação
guidelines
do
for
SARP
the
categoria
implantation
0,
of
que é o de
Category
menor
0 SARP,
tamanho,
the smallest SARP,
aguardando a diretriz de implantação
and
do
waiting
subprograma
for the
SARP.
guidelines for the implementation of this
O SARP
SARP
MEM,
subprogram.
aquele
SARP
material
MEM,
de emprego
which is the
militar que vai ter a
material for
rusticidade, que
military
vai ter,
use
atender a todos os
that will meet
requisitos
every
militares, as
military
demandas, as
requirement and
necessidades
demands and
da
needs
categoria 0,
of the
também está
category
aguardando
of the
a
zero
diretriz de
category
implantação do
0 is
subprograma.
also
Estamos
awaiting the
numa fase
implementation
final de
of the
revisão
subprogram. We
desses
are going
requisitos
through the
operacionais
final
para
review
uma
of the
publicação.
basic requirements
Em
for
princípio,
the
tudo isso
disclosure,
ocorrendo
and
no
this is
próximo ano, no
happening. This
curto
is
prazo,
also
em
all going to happen
2022.
in the short term, meaning next year or 2022.
Os principais requisitos desse material: autonomia de
The
no
main
mínimo
requirements
30
for this
minutos,
material
peso
are
total
minimum autonomy
inferior a 10
of 30
quilos,
minutes, weight
possuir
inferior to 10
line
kilograms,
of sight,
line
ou
of
seja,
sight
de linha
engagement,
direta, não
which is
precisa
direct line,
ter
without the need
alcance
for
maior do que 5
a
quilômetros,
larger range
atingir uma
than
altura de
5
operação de pelo
kilometers.
menos 3.000
It
pés.
should be able to reach
Ele
3,000
precisa ser
feet, must
transportável em
be
uma mochila por militar.
carryable
Então, militar
in
tem
a
que ter
bag by
condições de
one person,
transportá-lo
so
em uma
one
mochila.
person should be able to
A
carry
faixa de
this
frequência
equipment
tem que
in
ser
a
aquela
backpack.
adotada pelo Exército
It
Brasileiro.
must
Então, isso
use
é uma
the
grande
bandwidth
dificuldade.
used
E
by
essa
the
é a
Brazilian
questão que
Army,
também
which
não
is
se
the
pode adquirir
difficulty, and also the
no
matter that it
mercado
cannot be purchased
civil,
in
esse
the
material,
commercial
porque
market,
as
this material,
frequências
because
elas
the
já são
frequencies
fechadas. O
are
software também é
closed,
fechado.
the software is closed,
Ele
the
precisa
frequency
executar
range is
uma nova missão
specific.
num
So
prazo de 10
a
minutos,
new
ele precisa
mission,
executar a
if
missão,
a mission needs to be
voltar,
executed
10
in
minutos
10
depois
minutes,
ele tem que
the
estar em
equipment
condições
must
de
be
executar uma
must
nova
go,
missão.
return, and be
Seja
back
trocando
and ready
bateria,
for a new mission in
seja
10 minutes,
recarregando a bateria,
meaning recharging the
mas é o prazo
battery
de
or
10
whatever
minutos que ele tem
it
que
takes, but in 10 minutes the
voltar
material
ao voo.
must be reusable and ready to
Tem que
fly.
voar de forma noturna,
It must
sob
fly
chuva
at
fina ou
night,
leve, e permitir reconhecer
under rain,
indivíduo
whatever
a terra.
kind
Aí
of
a gente
rain,
fala da
and it
qualidade
must
do
be
payload,
operated by
no voo
one
noturno,
individual.
sob chuva fina,
Now we're
reconhecendo
discussing the payload, mentioning the payload under rain.
indivíduo
We
em pé.
we demand that
Já o
this
SARP,
equipment
o
be
categoria
operated by
1,
one
o
person standing.
FT-100 Horus, que nós
FTC
vimos
and
ali, foi
Horus,
adquirido a partir de 2013, ele
FT100
está
Horus,
entrando numa
acquired in
fase de
2013, is
desfazimento.
now
O
becoming
ciclo de vida
obsolete.
desse
Its
material,
lifespan
especificamente, é um ciclo de vida
is
muito
a
curto.
very short
Então, já
lifespan.
está nessa
So
fase de desfazimento, estamos
it
iniciando
is, we are in the stage of
formulação
undoing
conceitual.
the
Isso deve acontecer ao
conceptual
longo do ano de
formulation. This should happen
2022,
along
onde novos
2022,
requisitos,
where new
atendendo essas
requirements
novas
meeting
tecnologias
new
disponíveis,
technologies
serão
available will
elaborados
be
e a
designed,
partir de então
and
vai ser
from then on,
realizada a diretriz de iniciação num
guidelines will
curto
be
espaço de tempo,
elaborated in a short
retomando
period of
essa
time.
capacidade. O SARP Nauru 1000C é um SARP de categoria 2.
SARP
Ele já
Nauru
foi adquirido, ele vai ser
1000C, it has
recebido
already been
em
purchased. It will be
2022,
received in
já logo no início
2022, in
do
the
ano, já há
beginning of
previsão
the
de
year.
recebimento dele.
We
Ele
expect to
vai
receive
entrar num
this
processo
material.
de avaliação
It will
técnica
be
e operacional
assessed in
a partir desse
terms of
recebimento, e
operability and
ele vai fornecer aí,
technicality,
então,
and
SARP, sistema a 3
we will
aeronaves,
have a SARP
uma
for
previsão
3
de
aircraft
600
system with
horas
a
de voo ano por
prediction
contrato, com
of
treinamento de
600
pessoal, e
flight
sistema
hours per
logístico.
contract in the logistics system.
Os principais
The main
requisitos, dele:
requirements
autonomia de voo, então a gente já
our
vê
flight
aumento da
autonomy,
autonomia
so
de
we
voo já para
needed to be
7
increased
horas,
up to
sendo
7
5
hours,
horas sobre o alvo.
5 hours
Peso
alone
máximo de
on top
decolagem
of the target.
é a
The
150
maximum
quilos,
weight
possuir um
should
enlace
be
line
150
of sight,
kilograms,
voo na linha divisada,
and
possuir raio de ação
it must have
de
a
no
range of
mínimo
action
60
of
quilômetros, voar a
160
altura que
kilometers
permita a
minimum.
eficiência desses
It should
sensores, então
fly
ele vai ter uns
at
sensores,
a
tem que ter
height where
eficiência
the
a
sensors
50
would be
quilômetros,
efficient. So it must be
ser
efficient at 50
transportável numa
kilometers,
viatura 1,5 tom,
transportable and by a
acondicionado em
vehicle of
cases que
1.5
possibilitem
tons,
o transporte
and
em
should be
aeronaves militares.
it should be
Operar em faixas
stored
de
in
frequência
cases
de uso
to be
permitido
transmitted in
para o Exército
military
Brasileiro,
apparel. So this
operar de
for
forma
the Brazilian
continuada,
Army, that they
como a
should
gente viu
operate
ali
in a
também
continuous manner,
já
as
na
we
Guerra do
already
Golfo,
mentioned, as
voar
it was
diurno
done
e
in the
noturno
Gulf
sob
War.
chuva fina
They
ou
should be
leve,
able to
visualizar
fly
um
under any
indivíduo
kind of
a uma
rain, to
altura
visualize
de
individuals at
3.300
to visualize
metros
individuals at the
AGL.
height of
Então,
3,300
já é
meters.
bastante
This is very
ousado esses
daring.
requisitos,
Those
bastante
requirements are very
avançados.
daring. They're very
E a
advanced.
gente vai tentar
And we
visualizar aqui
will
agora
try to see
sobrevoo
now
desse
a
sistema de material de
flight
trigo. Não do sistema,
operation
mas
of employing this
não vamos ver o
material.
payload
Let's see the
atuando, vamos ver
payload
apenas uma aeronave voando.
in practice. We will see an aircraft flying.
Se puder colocar o vídeo pra gente aí.
Could you show us the video, please?
Se alguém tiver alguma pergunta, alguma dúvida.
Any questions for the moment?
Embaixo ali tem play.
There is, well, you can play it. There's a play sign, play icon below. Otherwise, we can skip this part too.
Então hoje é SARP considerado dentro
So
da
this is a
categoria que a
SARP
gente tem hoje da OTAN,
considered by NATO
dentro do
and
próprio
in the
exército.
category and by
Ele é
the
considerado
Brazilian
SARP de
Army, as we
categoria
have
2. Então
considered
notem
today.
o
It is
tamanho, a
a
envergadura
category
da
2.
asa.
So notice
Já
the
não é pequeno objeto voador, ele demanda uma logística bem
the
maior,
width of the wings, the wingspan,
adestramento maior
and
de toda a tripulação, de todo mundo que vai operar aquela carga paga, aquele payload.
so this will have an impact on the payload.
Pode passar adiante, ok?
Move on. Okay.
Então, esse foi o nosso SARP na Uru
Is the
1000C.
SARF
E agora,
Uru 1000C,
dentro de uma
Uru
visão
1000C,
prospectiva, já de,
and now in a
vamos dizer, de
perspective
curto prazo,
or
nós
short-term
vamos
perspective,
abrir
we
também
will
o
open
projeto
to
chamado
show you the
Munição
project
Vagante.
called Wandering
Está em
Ammunition.
estudo, os
It is
requisitos
still
desse
being
sistema.
studied. The requirements
A
of this system
gente
are being
pode
studied.
ter como
We
uma
can have a
referência
reference.
para esses estudos.
This can be a reference for those
Como
studies. We
exemplo,
can
eu
use an
trouxe aqui
example.
o
As for an example, I
AROP,
brought to you the AROP
aí, que tem ali comprimento de
that
2,5
has
metros, notem o pequeno
a
tamanho,
length
porém
of
com
2.5
elevado
meters.
alcance de cerca de
It is
1.000
small,
quilômetros.
but it can
Ele
reach
então
1,000
ele
kilometers.
executa
It executes
voo,
a flight.
uma munição projetada então
This is an
para,
ammunition
por isso que a
projected
gente colocou ali entre
for
vadiar, ele vai
wandering.
até o
That's why we
alvo,
mentioned
até
it
o
as we
local
call it
do
a
possível
wandering
alvo. Ele
device.
pode,
It will
essa
go
munição ela pode
travel all the way
retornar
to the
e
target, and it
realizar
can
o pouso
return
em
and
segurança,
land safely,
ou ela pode
or it can
escolher um alvo. Então
choose
tem
a
ali ainda,
target.
além dos
So besides the
explosivos, essa
explosives,
munição vagante tem
there is this
eletroóticos
this
que
wandering
vão
ammunition
selecionar
has
alvos,
the capacity to
podendo no
select
futuro
targets,
selecionar
and in the
inclusive
future
alvos
it may
de forma
select
autônoma. Isso
targets
ainda não
autonomously.
acontece.
This does not
O alvo
happen
é
yet.
selecionado de forma
the
remota
target is
e
selected remotely,
vai em direção ao alvo e explode
and this
junto com aquele
device
alvo,
moves
né?
towards the target and explodes. It
Autodestruindo-se naquele alvo.
self-destroys. It destroys itself on top of
Note
the
o
target.
payload, né, de 23
Notice the
quilos de
payload of
explosivos, né?
25 kilograms
Então é
of
realmente
explosives. So this
artefato
is really
que tem trazido
a
diferença
device that has
de
made a
capacidade,
difference in terms of
eficiência no campo de
capacity and
batalha.
science on the
Temos também,
battlefield.
num
Also,
curto ou médio
for
prazo,
the short
o
and
projeto
midterm, we
SARP
have
armado
this
também
the
está em estudo. Ele pode
armed
ser de
SARP,
qualquer
which is
categoria.
still under
Então a gente
study. It can be any
nem o projeto vai se
category.
chamar
The
SARP
project
armado.
is
Pode
going
ser
to be called
categoria
armed SARP.
0,
It could be
1,
category
2,
0 or 1 or
4.
2, 4.
Pode carregar
It
metralhadoras,
could
pistolas,
carry
mísseis,
rifles, machine
são
guns,
variados os
missiles,
aspectos. Então a gente está
many different
levando
aspects,
em
many
consideração
devices. So
nesse
we are
estudo
considering this in
os
this study,
aspectos
the
preliminares
preliminary
considerados
aspects
a
to be
extensa
considered,
dimensão
considering the extensive
continental do nosso
dimension
território
of
nacional,
our
a
national
presença de
territory,
grandes
the
vazios
presence
demográficos
of
também,
large
áreas
demographic
de difícil acesso,
voids, areas
extensão da
of
nossa
difficult access,
fronteira
the extension
terrestre,
of our
a questão da
land
vigilância,
borders, the matter
monitoramento e
of vigilance,
proteção de
monitoring,
estruturas
protection
críticas em
of
todo o
critical
território
structures all over
nacional
the
e de
national
áreas
territory,
estratégicas,
and strategic
e
areas,
também o
and
efeito
the effect,
dissuasor
the
e a
dissuasion
possibilidade também de realizar
effect,
uma
and the
negação
possibility
diária
of
sem, de fato, deslocar tropa
realizing
para aquele local.
let's say, a change of mind on the part of the
E
enemy
aí,
without the
passando
need
para o
of
nosso
deploying
tópico lá do roteiro, a parte dos
troops.
desafios. Um dos primeiros
So
desafios
our
que a gente
challenge is
se
one of the
depara
first
num
challenges we found when
subprograma
we work
dessa
when
envergadura
working with a
é a questão
subprogram
da
of this size is
multidisciplinaridade.
the matter of
O assunto,
multidisciplinarity.
ele
The
abrange
subject
questões
approaches,
de
it
cibernética,
includes questions
questões
of
de materiais
cybernetics,
explosivos,
explosive
abrange
materials.
todos
It
os
comprehends
temas,
every
todos os programas
theme and
do
program
Exército,
of
ele
the
abarca
Army,
todos os programas do Exército
all of the
e
programs of
impacta
the
todo
Army,
o
and
Exército
impacts the
brasileiro,
entire
sendo
Brazilian
todos os
Army
escalões, tendo os SARPs
in
menores
every
e de
level
menor
of
escalão,
the ranking,
os maiores, o maior escalão dentro do Exército, e
from
também
highest to
todos os
lowest,
sistemas
and every
operacionais,
operational
seja
system,
cavalaria, infantaria,
cavalry,
aviação do Exército,
infantry,
artilharia,
aviation,
dentre
artillery,
outros.
among others.
Outro desafio
Another
que o
challenge
emprego e o subprograma
that the
nos
employment
impõem
and the
é uma
subprogram
atualização
impose
doutrinária
are
constante e
constant
essa visão
doctrinary updates and
prospectiva
this
das
prospective
funcionalidades
perception of the
estarão
functionalities
estão
to be
disponíveis hoje
that
que
are
estarão num
available
curto
today and that will
espaço de
be
tempo
available in the
e estão
short
em
term.
desenvolvimento. Porque o ciclo
The
de
ones
vida
still in
se torna
development
muito
because the
curto quando a
lifespan
gente
becomes
inicia uma
short.
formulação
When we
conceitual
start
e
a
se essa
conceptual
formulação conceitual não for muito
formulation, if
rápida,
it's not
quando a gente
fast,
termina,
when we're done,
aquele material,
that
entre aspas, já
equipment
está
is already
obsoleto, vamos
obsolete.
dizer. Já existem novas
There
tecnologias
are
que dão
already
outras
new
capacidades.
technologies with
Então,
newer capacities.
desafio
So a
é o
challenge
processo de
is the
formulação
process of
conceitual.
concept formulation.
Isso não é só dentro do
And this
Exército
doesn't happen
brasileiro.
only in the
A gente
Brazilian
que mantém
Army.
contato em toda a
We
parte do mundo, isso é um
are in
desafio
contact with
no
people all
âmbito
over the
de
world, technicians all
todos
over the world, and this happens in the
os
scope of
exércitos por aí
every
afora.
army all around the world.
Até que a tecnologia
So
ela entre
until
num estado de
technology
amadurecimento e
reaches a
estabilize.
stage of maturity and becomes
Outras
stable.
tendências, e a gente pode
Other
considerar
trends that we
desafios
could consider are
tecnológicos
the
para o
technological
Brasil
challenges to
e
Brazil
até mesmo para o mundo.
and even
A
to the
questão da
world. The matter of
interoperabilidade, as arquiteturas
interoperability,
comuns
common
e
architectures,
abertas
and open
serão uma
architectures
tendência.
will be a trend.
A questão da
The
intercambiabilidade
matter
das
of
peças
the
de software,
interchangeability
firmware
of
e
software,
hardware.
firmware, and hardware
A
parts.
questão da
The matter
modularidade,
of modularity,
integração com sistemas
integration with
autônomos,
autonomous systems,
quantidade de dados
amount of
produzidos
data
também
produced.
aumentarão significativamente,
All
exigindo
of those will
também
increase
processos
significantly,
que lidem
demanding
com
processes
essa
that will deal
quantidade de
with this
informações que
amount of
serão geradas.
information generated.
Como outro desafio também
As a different challenge,
e
I would
tendência
also
é a
mention
questão
as
da
a trend
autonomia.
the matter of
Os SARPs serão
autonomy.
cada vez mais
The SARPs will
autônomos
become increasingly
por meio da
autonomous
inteligência
through
artificial e
AI
aprendizado de máquina,
and
serão mais eficientes,
machine learning.
eficazes,
They will become more
confiáveis
efficient,
e
more
por isso
reliable,
serão
and
mais amplamente
more
utilizados. Então,
broadly
prevê-se
used.
também, à medida que isso for acontecendo, uma
So as this
multiplicação desses
happens,
materiais
there will
no
be a
nosso
multiplication of
seio
these
civil
materials
e militar.
in civilian
Por
and
último,
military
como já havia adiantado, o armamento
horizons, if
também
you will.
ele vai ser cada vez mais
Weaponry also will
autônomo,
become
tanto na
increasingly
identificação
autonomous in the
até o
identification
engajamento.
and engagement.
Outro desafio que se avizinha,
Another
a
challenge
segurança
is
dessas
that is
informações
upcoming is
da,
a
que
security of the
tramitam,
information
operações
produced,
cibernéticas,
cyber
negação
operations,
de
denial
dados,
of
negação de
data,
navegação por GPS.
denial of
Então, são
navigation by
desafios que a
GPS.
gente
Those are
já tem
challenges that we
notado
have
essa
noticed
tendência
that they
e
will
a
probably
questão da
happen.
colaboração
And there is the
homem-máquina,
matter
uma
of
quebra de
collaboration,
paradigma em
man-machine
que o homem
collaboration.
ele vai
It's a
operar
paradigm
como com a
where
máquina, não
men or
comandando aquela
humans
máquina,
will
e
operate,
sim
not commanding
formando
machines,
uma
but
equipe.
forming a team with the machines.
Uma tendência também que a gente tem observado é
We have also
a
seen
questão, como já
an
falado,
upcoming trend
a diminuição do tamanho, do peso, da
is
quantidade, da
the
necessidade de militares para
decreasing
operar aquele
need,
material e a redução das
the
demandas
decreasing
logísticas para aquele
demands,
material.
logistics
Então, o
demands for
material está
those
ficando mais
materials. These
eficiente.
materials are becoming more
Ao
efficient.
mesmo tempo em que
At
está
the same
aumentando o
time,
alcance,
they
a
are
autonomia, a
becoming
carga
better
paga
in reach,
e
autonomy,
a
and
circulação,
payload,
a forma como esses
and
dados
circulation,
vão
the way this data
circular e
will
tramitar.
circulate
Não mais somente
and
para
operate
a
no
estação de
longer
controle
just
de
for
solo,
the
ela vai tomar outras
land
direções,
control station.
outros
They
interessados
will
que já
become
estão
controlled
lá
by other
também
parties,
no
other
campo de
interested
batalha.
parties that are already
Aqui nesse
on the
exemplo, a gente
battlefield.
pode
Here
observar
in this
SARP
example, we can see a SARP
de peso máximo de decolagem de
with a
25
maximum
quilos,
weight of 25
com uma
kilograms,
autonomia de
with an
12
autonomy
horas,
of 12
alcance de
a
120
range of
quilômetros,
120 kilometers.
também quebrando paradigmas
Also,
e colocando a gente em xeque quando a gente fala em categoria.
this
Qual
is also a
categoria
breakthrough in
esse
terms
SARP
of
ele se
category
enquadraria?
of this SARP.
O
What
peso
category would this SARP be?
das
Weight
categorias
is
mais
light. What
baixas, porém,
weight is
os
the
alcances
one
e
of the
a
smallest,
carga
the
que ele
lightest weights,
transporta,
and the
já a gente
payload
já pode
is
colocá-lo
one
numa
of the
categoria
largest. So
superior.
we
Então,
can,
qual a categoria você
what
está
would be the
utilizando para
category of
classificar
this drone? What category
esse
are we
modelo?
using to classify this
A gente
model?
vai ver também a
We
ampliação
also will see
do tipo
the
de voo chamado
expansion
B-Veloz.
of the
Isso vai acontecer
BVLOS
por conta
flights. This will happen
dos
because
satélites
of
de órbita
the
baixa.
low orbit
Há uma
satellites.
demanda também
There is a
reprimida
demand also
para
repressed
ser utilizada
for the use
essa situação
of this
e que vai
circumstance,
ser
and
contemplada
this will be contemplated
quando a gente tiver esses
when we
satélites de
have
órbita baixa. Foi
those
nos
low orbit
apresentado
satellites.
numa conferência
In a
bilateral que eu
bilateral
participei
conference I
junto
took
à
part of
Espanha,
in Spain,
apresentado para nós uma antena satelital com peso
a satellite antenna
de
was
cerca de
presented to
8
us with a
quilos.
weight of
Obviamente, uma
8
antena
kilograms.
satelital não de
Obviously, this
satélite
antenna was
geoestacionário,
not
mas
of a
de satélite de
geostationary
órbita
satellite, but
baixa
a low orbit
e que
satellite,
poderia ser instalado,
and
por
it could be
exemplo,
installed,
no
for
nosso
example,
SARP,
on our
que hoje
SARP,
tem requisito na URU 1000C,
that
requisito
today
veloz.
is
Se
the
for
URU
instalado no SARP na URU 1000C, ele
1000C
passa a ter alcance,
could
digamos, infinito.
carry. It
Ele
has an
sairia
infinite
daquela
range. It would be
de
it
SARP
would not
categoria
no longer
2
be considered
automaticamente.
a
Então,
SARP
as
2 category. It could
elas
carry
vão
this
ser revistas
antenna
também
and be considered a
por conta
different
dessa
category. So the
tendência,
categories will be
ampliação,
reviewed because of
a
this
ampliação do voo
trend
B-Veloz.
towards
Inclusive,
the expansion of
o
the
agronegócio
B
possivelmente também vai usar
flights.
amplamente
The agribusiness
este
will also
sistema,
use this
que vai
system
tornar
broadly.
mais comum,
This will
mais
become
barata essa
cheaper,
tecnologia
This will
E eu
make
tenho certeza que o
agriculture cheaper
agronegócio vai ser o
and more
nosso
efficient.
motor
So
no
agriculture
tocante
will probably
ao
be,
desenvolvimento dessa
agribusiness will
tecnologia.
probably be our
Outros
engine
sistemas de navegação,
to our
então
trigger to
a navegação
the
Veloz
development
vai
of this
ser
technology.
a primária ou a
Be
secundária.
Velox
A Veloz vai ser, então, o surgimento
navigation
de
will be the
os
primary or
SARPs, eles terão
secondary to
sistema
SARP. SARPs
primário
will
e
become a
secundário de
primary and
navegação ou
secondary. Will
terciário.
have primary,
Terão,
secondary,
no
and
mínimo,
tertiary
dois sistemas,
flying
dando,
systems.
então, uma confiança, uma
This will
confiabilidade
give
maior,
them greater
permitindo,
reliability,
então, que a
and this
gente
will allow
amplie o voo,
us
colocando
to
ele em situações
expand
mais próximas
flight
das aeronaves
situations, placing them closer to aircraft,
controladas.
controlled aircrafts.
A questão, então, da redundância
So
desses
the matter
sistemas,
of
tanto para o controle
redundancy of
da
those
aeronave,
systems for
quanto
the
para a
control of
transmissão
the
dos
aircraft and
dados.
for the transmission of data will become more common.
Então, aqui uma outra tendência, diante de tudo isso, diante de tanta
Another
confiabilidade, diante de
trend
tanta da tendência
in
de
this circumstance
tantas
and
reduções de incerteza,
before
vamos
the
dizer assim,
inclination towards the
o
reduction
tráfego aéreo, o
of
gerenciamento do
uncertainty, the
tráfego aéreo vai permitir que se
managing of
aproximem
air
aeronaves
traffic will
controladas,
allow the
remotamente
approximation between
pilotadas.
aircrafts remotely piloted
Vai ser,
and
então, essa
man-piloted.
tendência de
There will
aumentar
be
a
an increase in
regulamentação, a
the
regulação
trend
e
for
regras em
regulation
torno
of
desse tipo de
rules
voo.
around this kind of
Vai se ampliar
flight.
as questões chamadas de
We will
certificação
have that we will see a growth in the matters
e, como eu falei, o espaço vai
regarding
ser
to
compartilhado.
certification, and
As
space will be
aeronaves no
shared.
futuro
Aircrafts in the
irão
future
voar.
will
Aeronaves remotamente pilotadas
fly.
no
There will
mesmo
be
espaço das
remotely
aeronaves
piloted and
remotamente
man-piloted
pilotadas.
crafts
Bom,
will
aqui a
fly in the
gente
same airspace.
já traçou
Here
panorama
we
da
have already
categoria, que eu chamo
outlined the
tabelas de categorização
panorama
hoje,
of the
elas
category.
estão, entre aspas,
As I mentioned,
por
some of
conta
them are
dessa
quickly
questão.
becoming obsolete because of
Por
this
exemplo, à
question.
direita
For
a gente vê
example,
uma
on the
tabela
right you see a
em
chart
que o
where
SARP de
you
categorias
see
até 150 quilos,
a
como eu falei,
chart,
do
a
nosso
SARP
Nauru,
up to 150
ele
kilograms
já pode estar voando ali.
as the Uru
Ele seria
1000C.
classificado
It
pela
could fly
OTAN
here. It could be
como
classified
categoria
by the
1,
NATO
porém, se a gente
as
instala,
category
e é
1.
possível
But if
instalar
we
uma antena
install
satelital,
a satellite
ele
antenna,
passa
which is possible,
automaticamente para a categoria
automatically
3.
it will become
Há
category
documentos, por
3,
exemplo,
a
já
category 3
esse
device.
documento aqui
This document
da Espanha,
from Spain
que já cita as
already
questões
mentions
que a separação entre
these
alguns
matters
SARPs
of the separation
táticos
between
e de combate é
tactic and
mínima.
combat SARPs, which is minimal.
Então, o que de
So,
implicação traz isso para
what
a
are the
gente? É que
implications
realmente a gente tem
of
que
this
fazer
current
a
situation?
escolha
We will have to
desse
choose
material
the
dentro daquela
material
primeira tabela, aquele primeiro
according to the
figura
first
bagunçada que a gente mostrou.
first thing, the
A
first
escolha
slide I
desse
showed
material
you.
tem
The
que
choice of
vir
this material
logicamente como
must logically come
na engenharia de requisitos,
from
pela
requirement
necessidade, pelo
engineering
requisito.
according to needs.
Aí sim, depois atendendo a minha
Then,
necessidade, de atendendo ao meu
once needs are
requisito,
met,
se eu quiser
requirements are met,
classificar,
if I
eu
want
vou
to
classificar o meu
classify the
SARP dentro de uma
craft, I
categoria.
can classify
Mas
the
não é
SARP
um
within
processo
one of the
inverso, que a
categories.
gente escolhe uma
But
categoria
we're
e
doing
depois
the
vê
opposite
quais as
process. We're choosing a
necessidades que aquele
category and
material
then
vai
determining which
atender.
requirements that equipment should meet.
Uma próxima e penúltima tendência, já indo quase para a conclusão,
A
para
new
não
trend,
cansar muito
the new before
a
last,
assistência,
last before last,
a gente nota aqui,
we
então, que os SARPs,
notice that the
eles também
SARPs
estão sendo
are
empregados
also being employed
menores, mais leves, com armamentos mais leves.
as they
Como a
become
gente pode
smaller,
observar,
lighter, with lighter armor.
este armamento,
As we can
míssil
see,
guiado
this one
de
is carrying
3
a
quilos,
guided missile of
podendo
3
então
kilograms, so it can
SARPs menores,
be used
inclusive
on smaller
a
SARPs,
gente poderia considerar
and
que
we could
seria
even
possível
consider it
realizar
possible
uma
to
integração
accomplish an
desse sistema
integration
armado
of
com,
this armed
por
system
exemplo,
with,
o
for
Nauru
instance,
1000C.
the Uru 1000C.
Eu poderia estimar que
I
seria
could estimate
ou será possível
or make it possible
futuro
foresee.
próximo.
I could foresee
como
this
última
happening
tendência,
in a near
ampliando
future.
aí
So as a last
esse mercado
trend,
militar,
expanding
a
this
gente
market,
observa
this
a
military market,
ampliação, né?
we can see
Quantidade,
the
a gente vê a
expansion
Nigéria já
as
adquirindo
Nigeria already, for
materiais
instance, has
de emprego
acquired
militar, SARP,
military
de grande,
equipment,
inclusive de grande
SARPs,
porte, com grandes capacidades,
including large
ali para
SARPs with
atuar,
large
né,
capacity
no seu entorno
to
estratégico.
act on their strategic
Há quem
surroundings
diga
or borders.
que o F-35, aquele
Some say
famoso
that
caça
F-35,
americano que
the
decola na
famous
vertical,
US
ele
aircraft that
seja
takes
o
off in the
último
vertical
projeto
position,
de caça
it will be
militar
the last project for military
com
aircrafts,
tripulante a bordo.
for manned
Há quem diga que
military
em
aircraft. Some
2030
say that
os
in
SARPs
2030,
armados poderão
armed
constituir
SARPs
cerca de
may
50%
maybe
do
50%
poderio
of
militar
the entire
daquela força
fleet
armada.
of the armed forces of certain countries.
E como última tendência e
And as a
desafio,
last
aquele
trend and
cenário que a
challenge,
gente
that
viu
scenario that we
no
saw in
início,
the beginning,
a gente pode
we
observar esse
can
cenário
see
mais adiante,
a
ainda que
different scenario
parecido,
ahead,
com
even though it
algumas
may look like
diferenças, né?
the previous one with a
Então,
few
a
differences.
operação veloz, o que
So,
permite
fast
uma
operation that
redução
allows
da
for
altitude
reduction
para
in
poder
altitude,
observar melhor o
so we
alvo,
can see the target better,
possibilitando que o
enabling
payload seja mais leve,
payloads to be lighter,
vamos dizer, uma estação de
let's say a
controle mais
control
próxima
station, a
ou
closer
do outro
control
lado
station,
de
or
uma,
on the
vamos
other
dizer, de
side
uma serra
of
ou de
a
um
mountain
objetivo,
or an
fazendo
obstacle.
ali duas estações, né,
We could
controlando
have a
a
couple of
transmissão de
stations,
dados
the
e voz
data transmission and
diretamente do
voice
SARP. A
transmission
gente viu
directly from the
no
SARP, as
primeiro
we could
cenário em
see
que ele
directly in the first
mantinha o contato
scenario.
apenas com
It kept
a estação de
contact
controle,
only
ele
with the control
transmitindo
station.
dados
It transmitted
diretamente
data
para os
directly to
sistemas
the
operacionais, não
operation
só
system,
transmitindo, mas também como
transmitting
recebendo e
and receiving and
retransmitindo,
retransmitting information, as you saw
e uma série
previously,
de outras inovações.
and a series of other innovations.
E aí eu chego na conclusão,
So
em
to
que a
conclude,
gente passa as seguintes considerações. A
we
gente
can
observou
consider
na evolução histórica
that
que o SARP
during the historic
ele
evolution
foi, ao longo
of
dessa
SARP,
evolução, integrando tecnologias que estavam disponíveis
this kind of
naquele
device
momento.
integrated the technology available at each time,
E a gente vai
each period
observar
of its
isso
evolution.
com as
We can see
tecnologias
this with the
disponíveis
available
agora, 5G,
technology,
inteligência
5G,
artificial,
AI,
internet das coisas,
Internet
tudo
of
isso vai ser
Things.
integrado
All of this
no
will be
SARP.
integrated on SARP.
A questão das baterias mais eficientes vão ampliar ainda
More
mais
efficient
esses
batteries
alcances, vão
will
ampliar ainda
extend
mais
its
a
range
autonomia
and
desses
autonomy.
materiais. A questão das fontes renováveis.
The matter
Então,
of
tudo isso vai ser incorporado.
renewable energy
As
sources,
baterias solares de carregamento solar.
solar-powered
O SARP no
batteries.
futuro provavelmente
SARPs
ele
in the
vai
future will
fazer
probably
voos
fly
ininterruptos por
uninterruptly
dias sem necessitar
for days
realizar
with no
pouso.
need to land.
Nós vimos também então que isso veio
So we
o SARP é
also
da
learned that
integração de
this
tecnologias que estão
is the
disponíveis.
result of
Então, isso
the
é
available
fato. É só pensar no
technology. This
que
is a
está vindo
fact.
de tecnologia,
All you need to do is
como
think
ser
about
aplicado
the
aquilo no
technology being
SARP,
developed and
a gente
how
já imagina o
that
que vai
can be
acontecer.
applied to SARP, so we can already imagine what's going to happen.
Processo de obtenção, então,
Processes for
a gente viu que é
achievement
importante a
for purchase.
gente
We
primeiro determinar a necessidade. Qual a
learned
necessidade?
that we firstly need to
Brasil é
determine
país
the need. So
continental.
what are
Eu
the needs?
preciso
Brazil
ter
is a continental
alcances
country. Do I need to
continentais?
have
Preciso ter
continental
alcances
range?
continentais.
Surely I
Eu
do.
tenho áreas de difícil
I
acesso.
have
Tenho
areas
eu
of
tenho uma
difficult
fronteira de
access.
mais de
Do I?
15 mil
Yes, I do.
quilômetros
So I have
quadrados.
a
Tem
border of
sistema
over
de fronteiras,
15,000
inclusive
square
no programa
kilometers.
estratégico do Exército,
So
temos o
the
Astros
Army Strategic
2020,
Defense
programa
Program
também
has
estratégico do Exército, que hoje nós temos
the Army
desenvolvimento
has
de
a couple
mísseis
of programs
que
that
alcançam
develops
cerca de,
missiles that
é o que eu posso
reach
dizer, 300 quilômetros.
a target at
Então, esses
300
alcances,
kilometers
eles aumentam
away.
como a gente
So
já tinha
this distance
conversado.
will increase, as we already
Essa
mentioned.
integração de novas
This
tecnologias,
integration
como
of
já
new
foi falado,
technologies, as mentioned,
tudo isso vai
all of
continuar
this will continue
nessa ampliação
in
desse
this
emprego dual,
expansion of the
tanto
use
a
of
esfera
dual use
pública, quanto a militar, quanto
by
o civil,
civilians and
vão ser
military
ampliados
will be
ainda
expanded
mais do que a gente possa,
even more than
do
we
que já
could
ocorreu. Então, vamos dizer,
imagine,
vai
and
continuar
that
dentro de uma
than
curva
what has occurred.
exponencial.
We will continue following an exponential curve.
E aí, como desafio diante de tudo
As a
isso,
challenge in
a
face of
gente
all of this,
encerra dizendo que é necessário, dentro de um
we must
subprograma
consider
como
it is
este,
necessary
extremamente
in a
cheio de
subprogram
desafios
like this,
complexos,
full
a
of
gente precisa
challenges
gerar
and
sinergia entre
complexities. We need to
todas as
generate
partes
synergy
interessadas,
between the
ou
interested
seja, poder
parties,
público, estadual,
meaning the
municipal,
states,
privado, militar,
municipalities,
dentro do
federal
militar, todas as
government,
forças armadas,
military. All the armed
estabelecendo
forces should
parcerias
establish
público-privadas,
PPPs,
buscando
public-private
fontes de
partnerships,
financiamento. O
seeking
SARP ele
for
tem um emprego
sources of
civil e
financial
que
sponsoring,
pode ser operado numa parceria
and
em
we can
proveito de
operate
fazer a
these
segurança de um
equipments
determinado ponto
to
e
perform
com o
security
pessoal militar eu
from a
já vi
certain point
parcerias
on.
nesse
So I've
sentido,
seen
porém o
partnerships in this
material
sense, but the
ele é
material
pertencente
belonged
ao
to
militar, mas ele por
military
vezes
corps.
dentro de uma parceria ele pode executar
Sometimes
missões
in
de segurança
partnerships,
em
they can be
determinadas
used to
áreas.
carry out security actions in certain areas.
A gente vai ver então
So we will
essa
see
evolução dessa
this evolution
capacidade
of this capacity,
operacional, técnica e aí como desafio
operational and
a
technical
questão da
capacity,
gente fazer essa
and
sinergia,
it is a challenge
buscando aí
to promote this
fomentar
synergy,
a base
to promote
industrial de
the
defesa,
industrial
muito
basis of
importante
defense. This is
para
very
as
important
Forças Armadas
to the
essa
armed
base
forces,
industrial de
this
defesa.
industrial basis.
O SARP então,
So
como
SARP
conclusão, a gente considera ele como um vetor
is
que
considered a vector
vai assumir a liderança da modernização que
and
já
will be
está
the
em curso
leader
na Força
of
Terrestre,
the
a
modernization that is already
modernização
happening
doutrinária
in the
e
armed forces.
tecnológica,
It will
como a
be
gente
a
citou
vector
aqui,
of
já
doctrinary and
está em curso,
technological modernization
mas
that is
ele,
already
assim
happening.
que a
But
gente
as soon
lançasse a
as we
diretriz de
launch
implantação,
the
eu tenho
guidelines for the
certeza
implantation
que
of
esse nosso
these
subprograma dentro
devices,
do
of the
programa
SARPs,
OCOP,
this
na quarta subchefia
subprogram
do Estado-Maior, vai assumir
will take on
certo protagonismo.
a certain
Lógico que todos
protagonism.
os
Of
sistemas
course,
são importantes,
all the
o SARP
systems
não
are
é
important
sistema em
and
si,
SARPs are not
ele
a system
dentro de sistema
themselves.
maior,
SARP is not a
pode ser
system in
considerado
itself. It can be
subsistema, então
considered a
para
subsystem.
ele funcionar
So
e
for
ser
it to
eficiente,
work
ele
and
precisa de
become
todos os
efficient, it
outros
needs the
sistemas
other systems working properly,
operacionais.
all the other operational systems.
Daí, eu encerro, passei todo esse
So
roteiro.
I
Espero ter
conclude, and I
atingido
hope I have met
esses três objetivos,
these
ter
three
apresentado
objectives:
a evolução histórica do SARP, apresentado a evolução no EB
the
e as
background
tendências e
of the evolution of
expectativas
SARP in the
futuras
world,
da evolução do
in the
SARP
Brazilian
no
Army, and the
mundo
trends and
e também
expectations
no Exército
around
Brasileiro.
SARP
De
for
forma
the
rápida, me
future.
coloco à disposição para
I am
dúvidas,
at your
perguntas,
service for
esclarecimentos
questions,
adicionais.
clarifications. Thank you very much for your attention.
Muito bem, senhores.
Very well.
Agradecimentos ao Coronel Leonardo por sua
Our
participação.
thanks to Colonel
E, bem, nós temos agora
Leonardo for
vou
his
fazer chegar o microfone até o senhor.
presentation. So
Construa sua
let me bring you the microphone so you can ask a question, sir.
Obrigado.
Thank you. Good afternoon, ladies and gentlemen. I'm Major Brigadier Carminati. I am a retired military, and I am in charge of defense and security. I used to be, and it's a pleasure to be able to watch your presentation. And here I have a question today about SARPs for defense. I don't know if you made any comments on that, but we worked in 2012 in a joint Rocky, which evolved along the years, and we working at the Ministry of Defense know how important, how difficult it is to harmonize the interests of the three forces and to have a defense SARP. Could you comment on that? Is there the purpose of developing a single SARP that will meet the needs of the three forces?
Boa tarde,
Good
Major Brigadier.
afternoon,
Obrigado pela
Major
pergunta.
Brigadier. Thank
Temos
you
sim.
for your question.
Estamos em
Yes,
tratativas.
we do. We are
Há
currently
nesse momento grupo de trabalho exatamente para atualização
working
desses
with a work
ROCs e
group for
requisitos
the
operacionais conjuntos.
update of the
Então, está em curso
Rockies
esse
operational
estudo
costs and
e
so on. This is under study,
grupo de
and
trabalho
this work group
chegou a entendimento,
reached an understanding,
está agora exatamente
and now we are
processo
precisely in this
decisório,
ongoing
buscando aí então a gente obter essa
decisory
capacidade
process to reach this
de
capacity
conjunto que
of a
atenda
joint SARP that meets
todas as necessidades
the demands
das três
of
forças
the
armadas,
three armed
que são
forces,
muito
which
amplas
are
as necessidades.
broad
Então,
and
assim,
many. So
esse estudo está sendo realizado exatamente
studies
nesse
are
momento.
being
A pergunta é
carried
muito
out
pertinente.
right
Muito
now. This
obrigado.
is a very pertinent question, so thank you very much for that.
Muito bem. Nós temos mais
Very
alguma
well.
pergunta?
Any other questions?
Certo? Bem, não sendo o caso,
Very
então,
well.
mais uma vez, muitíssimo
Thank you
obrigado
very
pelo
much,
tempo,
Colonel,
estarem
for your
conosco,
time, for
compartilhando
your
seus
contribution,
conhecimentos,
for
enfim,
sharing
trazendo,
your knowledge.
acrescentando bastante no nosso evento.
You
Muitíssimo
have added much to our
Obrigado a
event. Thank you very
vocês aí.
much.
Obrigado
Thank
à
you for
assistência.
your
Boa
audience.
tarde.
Good afternoon.
Me coloco à disposição, então, nos
I'm-
contatos que estavam apresentados.
I am at your
Obrigado.
service to answer your questions. You can contact me
Muito bem.
through the contact info on my last slide. Thank you very much. So, to resume our activities,
Daremos sequência, então, às atividades
We'll continue
previstas para esta tarde
the
de trabalho.
activities
Nós teremos a oportunidade
in the
de
program
ouvir
for this
neste momento, senhoras e
afternoon.
senhores,
We will have the
as
opportunity to
palavras do
listen to
brigadier
the
do
words of
R1,
Brigadier
José Wagner
of the
Vital.
R1,
Nós temos convidado
José
Brigadier
Wagner
Vital,
Vital.
por favor.
We'd like to invite
Ele é
Brigadier
coordenador do
Vital,
Comitê
who is the
Aeroespacial do SIND, esteve conosco
coordinator
ontem,
of
nos
the
trazendo aqui também suas considerações. E
Spatial
volta
Committee,
focado num assunto
to
dos
bring
space
us a
business, né? Trazendo aqui
discussion of the
considerações sobre
space
o
business,
crescente space business
the
e
growing
aspectos de
space
segurança
business, and
cibernética.
some aspects
Brigadier,
regarding
prazer em
security,
recebê-lo novamente conosco.
cybersecurity.
Privilégio de tê-lo conosco
It's a privilege to
para mais
have
essa
you
etapa do evento.
among
Muito obrigado,
us.
você tem a palavra.
You have the
Obrigado.
floor.
Mais uma
Thank
vez,
you
obrigado
once
pela
more.
oportunidade.
Thank you for the
Obrigado pela
opportunity,
presença,
for your
Brigadier
presence, Brigadier Carminati.
Bem, eu vou colocar pequeno aspecto.
I'd like to mention a
preocupante,
very worrying
que é
aspect,
a necessidade
which is
de nos preocuparmos com uma grande rede de computadores que está
the
em órbita, né, que está sendo cada vez
great
mais utilizada
wide web in
e que
orbit
interfere
now.
diretamente na
It's
nossa vida
interfering in our life,
e realmente está
and
cada vez
really
mais se mostrando presente
is
acaba virando alvo de
present,
preocupação
and
nossa.
it's a worrying factor,
Consiga ter uma vida moderna
so
atual,
that we
utilizando
would have a
sistemas de
modern
espaciais cada vez
life
mais
with
presentes
using
e que os sistemas de
space
segurança,
systems,
principalmente cibernéticos,
especially the
estejam
cybernetic ones,
preparados
cyber
para esses
ones,
próximos projetos
that should be
a
prepared
permitir que seja
to
utilizado
enable
todos os
us
serviços com bastante segurança,
using
evitando problema tanto
the
de segurança
services
pública,
with
cyberterrorismo
security,
e outras coisas
with
mais,
public
né?
security, security
Nós
against
somos do
cyber
SIND,
threats.
Sindicato das Indústrias
We are
Materiais de
from
Defesa,
SINDI,
né?
the Union
Eu
of the
trabalho
Industry for
apoiando, né,
Defense.
Comitê
I
Aeroespacial
am
do
the
SIND, que se
support
preocupa com esse
for
aspecto das
the
empresas de defesa.
aerospatial department of Cindy. So I
Mas que
have
tipo
those
de business
worries.
nós
What
estamos
type of
falando?
business
Estamos
are we
falando de
talking about?
business de
We're
uma
talking
maneira
about
geral.
a
Todos
general
os
type of
serviços do
business.
espaço terra,
It could be
quanto espaço-espaço, no
space,
mercado
Earth,
trilionário,
space, which is a
que
trillionary
normalmente está
market
em torno de
that
440 bilhões por
it's
ano,
around
mas que até
440
2030,
billion
projeções de alguns
nowadays,
bancos
but there is a
desde
projection of some days,
vai
some
chegar a
banks that
1,4 trilhões,
estimate that
né,
we'll reach
em menos de 8
$4
anos.
trillion in 8 years
Vai
around.
triplicar em 8 anos.
It's
Então,
going
a
to triple
gente
in 8
tem uma
years.
coisa séria,
So
né?
this is very serious.
Esse panorama que
This
essa
is
consultoria Space Tech Analytics
overview that
fez,
Space
uma
Tech
base de dados que a
Analytics
gente
has
observa
done,
que
and
já
where we
existem cerca de
observe
4 trilhões de
that
dólares de
there
investimento
are already
envolvido
$4
no
trillion
espaço.
of investment
Fora,
involved,
essa consultoria
and
ela
this
mapeou que existem pelo menos
consulting
5
has
mil
mapped
investidores, 160
that there are already 5,000
hubs de
investors,
pesquisa e desenvolvimento
150 hubs of development and 130 governmental organizations, 20 sectors. And it's also the time for great constellations. Starlink, for example, that was already mentioned here regarding our negotiations to provide social services in remote areas like the Amazon, high-speed internet, OneWeb. That is also a constellation, Telsat, that used to use stationary satellites, and now it's starting to change to low orbit satellites. And so you to have an idea, it has authorization to launch 12 thousand satellites, and there's a provision of 40,000 satellites. So we see it's a huge heightened number. And so Starlink, around those next 3 years, there's already 2,000 in orbit. There's an average of 300 Telsats and so on. We already have spatial tourism around $1 million. With around $1 million, you can do that type of trips. With $250,000, you can already do those trips. Yesterday, it was around $1,400. Here, you have other revolutions in the uses of spaces in many applications. We have images to the controls. It's a population using spatial technology. For example, Portugal is already have a national space center, space agency. There is a serial scale production of satellites with the same scale that the automobile industry has. You have new launchers of small satellites, and their business, their companies, the startups, lots of startups that are around the world. Regarding the costs of launching, the historic cost of it has decreased with Starship. The trend is to decrease to less than $100 when they start to operate in 2024. The cost of launching for low orbit is going to be around $20 kilo. It was to be $50 a kilo. Now, for example, to launch satellites like that, the Rocket Lab, it's possible already to launch with the same cost of launching a small airplane. From $50,000 4 years ago, now it's around $5,000 with this type of small rocket. And from 2 years, it's going to drop a lot more. Any small company can hire spatial services. There are initiatives like it happens in England that has created Surf Satellite Technology, which is a company from Airbus. So you have many flags from different countries, many in Africa, that already were trained by Surrey and are able to build their own satellites. Nigeria, for example, has 5 satellites. Algeria has bought some from Sirius, but other companies in other categories of Airbus, and so on. We observe new opportunities, for example, the Internet of Things with the utilization of satellites. The Starlink constellation, for example, is going to explode the Internet of Things. It's comparable to the starting of the 5G. Management of assets, it's already said of space 4, precision agriculture, satellite images for agriculture. It was said here that SARPs will utilize satellites to change categories and operate without stopping. With all that, Brazil has taken his first step with the agreement of technological safeguards. I've said that in my last speech that allow us the space explorations with American technologies. That was an important step for our Brazilian industry to join the international space industry because it's possible for special industry companies wouldn't need to change the country, have a lawyer in each country to launch its artifact in its own country with its own laws. It's possible for the companies to build its its buildings, for example, in Embraer in São José dos Campos. So this safeguards agreement, Deputado Bolsonaro, Representative Bolsonaro has talked about that. How was the way to get that agreement? This first step was taken. It allows the launching in either a vertical, either in a runway in Alcântara, with the advantage that some other countries would like to have. This area close to the ocean is completely under our jurisdiction. So we can have any launching with no coordination with other countries because we have complete autonomy in that operational area, either for launching payloads, either to receiving loads. For example, the result of orbital industries that are making vaccines, for example, can be received in this area. Few countries around the world have this possibility. If a Starship is interested in launching from Brazil, it would be possible to build a floating platform besides the Spatial Center of Alcântara and do the same launchings so that we can notice the level of application in public security. For example, you have an animation when Ranger Navy ask information from a satellite, and another satellite execute those informations and send whatever it's detected of suspected activity. For example, if there is a discharge of oil, then the boat is capable of approaching that in a more precise way. You can also have response launches where nano launchers can send small satellites, heighten the communications capability, permitting the coordinations of actions, for example, in the combat of fire. All that has to be protected. We have to think, what are the threats? You have the Consulting Committee for Space Data System, which is a committee in which various organizations around the world get together to do reports on cybersecurity for spatial systems, space systems. Among those researchers is the definition of a threat in the cyber definition, the cyber sense, is the capacity of the intention of threat and the risk, and what organization is going to be targeted by that problem. So the system suffers the threat of being attacked, and the threat depends on the capacity and the intention of the agent of causing hazard. So to distinguish the difference, there is capacity plus intention. We can think about cyber terrorism, criminal activities, military activities against adversaries, and risk is a probability plus damage. So it's a very high risk for those spatial systems that have to be considered when planning the system. So to make it resilient and safe, and the more useful and necessary, the more we have to think about resilience. Here we have the pictures regarding the report of CCS. Information saying that information, which is an asset, had to be protected, is an environment very susceptible of attacks from hardware, from softwares. So there's a very complex environment that has to be considered. We have here a scenario where the agents and criminal activities doing their attacks on their target, from ground control to their communication systems. And currently, the satellites themselves are being attacked. For example, we have Russian satellites that have hacked American satellites of Intersat and other French satellites, provoking the United States and the Armed Land and Space in 2019. That's why France is about to launch in 2024 a constellation of Ranger satellites with laser, armed with laser to face those threats. They find the weak point in the adversary that can cause different types of impacts, different types of damage in the mission, the sensors, so on, causing, in the end, an impact on the delivery of the service in various grades, depending on the interest of the agents that's causing the damage. Could be the break of confidentiality, for example, up to the complete destruction of a service or a system. We have here the origin of the threats. It could be adversaries in the environment itself, could be a structure, or could be an insider. The adversary, you have terrorists, criminals, intelligence service, political activists, computer hackers, competitors, commercial competitors. All adversaries could be originators of cyber threats. In the environment, there are natural disasters that could destroy a ground control station, could be disaster caused by man action or landslides, lack of electricity. It could be structural too. A problem with the software, the failure itself causes damage. And also the insider. It could be maintenance, dishonest staff. It could be dishonest staff within the system. Could be unhappy employees, inadvertent actions that could originate a leak. the origin of the agents could be passive or active. In the active case, you have to have a source that trigger a sequence of events. And the active menaces could be against spacecrafts, ground systems, and communications. In the case of an active threat, it's necessary an agent. For example, blockage of a system of communications, attempting to access a controlled system, resulting in a leach of confidentiality, reproduction of communications that masks in an authorized size signal, bugs. We're used to listen that here on the ground, but everything like that can happen in a computer network that is on orbit. They used not to worry about that, but they are very much vulnerable. Security engineering of INCOSE that works with system engineer is already thinking on robust architectures for the satellites so that you have less vulnerability. Malicious softwares, viruses, trojans, passive menaces, passive threats. Is that one that you don't need an agent? No, no need of a source of damage. For example, leakage of communications. Russians have done that. Russians have already leaked and the analysis of traffic so that they are capable of act over the information without necessarily being able to read the information. For example, if they know where you're communicating to or what is the interest that's being protected. Sometimes your adversary with that type of attack can identify who are your clients, who are your providers, what's your logistic chain, and anticipate and steal your market. It's not necessarily a war threat. There is also the commercial war. This is an example of potential threats against space missions. You have space elements, network elements, control elements, and the users themselves. Besides the hardware damage, failures. We have an example here of spatial communication system. Up there you have the spacecraft, satellites, they're flying, they're under attack always. You have a database on the ground, control, communication links. All that architecture present weak points that can be explored to a cyber attack. This is an example of analysis of threats for a spatial system. So here you can see in this table we call this assessment. It considers on the left the threat, their impact, their probability of occurring, and the security mechanisms that can be used. For example, the threat of corrupting data or of attacking physical structure, interception of information, jamming, denial of services. So do you have the probable impacts there? and the mechanisms that can be used over that threat. So that type of assessment is important when you want to have a resilient system against cyber attacks. At the same time, under communication also you have masquerades, a replay that is one when you double what's been transmitted to get the transmission, software threats, and in the end, you have unauthorized access when you steal a password or breach of passwords, and tainted hardware components, which is an intent of causing problems to components to hardware. Under that, you have, for example, malicious systems. Is inserted inside the hardware, or an instability that is caused to a component. To conclude, I have a table of the assessment process. This is a general one. When you prepare the analysis, you have to see the framework of risk. You assess considering identification of the threats, of the vulnerabilities. There is a determination of the possibilities and the probabilities of those facts, which are the degree of impact that threat could cause, and finally you determine the risk, which is a measure of probability. Depending on what, you take measures that could be, for example, a deal with that, or intervene so to heighten the robustness of the system. You communicate the result to whoever is doing the design or operating, and you maintain the assessment because this is a constant process. In this space, you have interactions with the world and authorizations, the changing of this fact. So you have to have a routine, and finishing one, you start another one. And in the end, you have here a routine of assessment customized for a spatial mission, not only communications. For example, you construct scenarios, identify the threats for space missions. For example, if it's spatial tourism, hotels, transportation, mining, you can do monitoring of space, communication, space, moon, gateways to the moon, fabrication of cement in the moon, mining of helium for nuclear use on the Earth. So it's infinite, the number of missions. Whatever we do on Earth can be done in space. It's a little bit like when Europe has established in America. Everything that was to be done there become done here. That could be done with spatial mining too. Material that can only be built outside of the Earth in microgravity could be most valuable products of technology. With that, you identify candidates, security mechanisms to counter each threat, and if it's possible, if you can curb that threat, it becomes just a risk. If the threat can be explored for any malicious agent, it becomes a vulnerability that would permit the cyber attack. So I hope I was able to show you the common worries in the spatial world. They are present in our business, that along with the investments in those systems, we can foresee that up to 2030, we're going to be 50 to 100,000 on orbit around the Earth. So it's exponential. So the risk is also heightening, affecting transmission lines, power plants exist, and so there is a necessity of worrying about the security of those systems and of assessment of the risks in spatial systems. This is what I wanted to tell you. Thank you for your attention. I can answer your questions if there is any. I have my contact information on the screen. I'm the Director of Innovation in Sinti. You may ask me through the emails too. Sometimes we learn through the questions. Thank you. Thank you, Brigadier Vital, for your presentation. Is there any questions regarding this presentation? That will be the perfect moment for that. If it's not the case, thank you, Brigadier. It's a privilege to have you in our event. Thank you so much. Ladies and gentlemen, we will continue the activities for the afternoon with the next presentation, when we have the opportunity of listening the Professor Celso Vilas Boas. Please, I would like to invite you to come to the stage. Professor Celso is of the Federal University of São Carlos, and his theme, the stage is at your disposal, Professor. The theme is the quantic computing revolution, and he would like to answer how Brazil will enter that game. It's a privilege to have you with us. Thank you. Firstly, I would like to thank for your invitation for this opportunity and to talk a little bit about quantum computing. It's an area that we've been studying for a long time. I would like to thank the invitation of General Okamura and all the organization. What's quantum computing? How Brazil could be in that game? How could Brazil could be a player? Would Brazil want to be a player? And that's what I would like to speak to you about it. What's quantum computing? It's a new way of processing information. We are adjusted in our day-by-day actions, notebooks, desktops, cells, phones, with their processors. Everything functions with the classical logic of a bits, transistors, etc. And with the quantum theory, we've noticed it's possible to process information, treat the data with another form. It's possible for the quantum computing that it would be overlapping and grouping. We have bit 0 and bit 1. In quantum computing, you also have bit 0 and bit 1. In quantum, you can have both of them. That's the great power of quantum computing, this overlapping with a very different way of working. This form of treating data, I'm going to talk a little bit of the background. There are some promises around that. Some of them is its capacity of solving problems that not even the supercomputers could be able to solve. So it promises a great revolution in the treatment of data, its capability of simulations with no other. And so there are many governments and companies highly investing in this area because they notice it's going to be a disruptor in computing. Computing itself is revolutionary. Nobody would imagine themselves without a computer. So computer is versatile. It's in medicine, information, is in learning and satellites, in everything. So quantum computing comes to revolutionize even more, get to another level. I've heard Brigadier's speech, excellent one. I was enchanted by it. The transformation we're living today is extraordinary. 2,000 satellites in a very near future, 50,000, everybody connected to each other with easy accessibility. So quantum computing is going to be very important. The understanding of a lot will be happening. But at the same time, a message I want to give to you, beware. The promises are equivalent to the possible threats. Quantum computing can do a lot, but doesn't have competency to do everything. So we have to be cautious. We have to invest in development, research, and that's why we need partnerships with companies, government, and universities. I'm going to tell you a little bit of the story, just for you to know what is quantum computing. Today we hear a lot this term, but it's not as new as it seems. It was born in the 80s. A physicist that has talking about that was Richard Feynman, Nobel Prize, well known in physics for its didactics, for his teaching ways. And another of his characteristics was his possibility of explaining the Challenger explosion in the 1987. What happened? Why did it explode? Many engineers and scientists trying to explain what happened, and it was Feynman that was able to explain. So in 82, he proposed the use of quantum systems to simulate other systems. So his rationing, it was that the nature nowadays, the one we see, its origin is in the quantum mechanics theory. The world we live is quantic. So nothing better than other quantic systems to simulate nature. For example, in molecules, how can we simulate a molecule? All chemical reactions inside a molecule, what's in the back of that is interaction of atoms, electrons, and everything can be explained by quantum theory. So to precisely describe, we have to describe in accordance to the quantum theory. And so the classic computers have limitations. From that, people start to think how quantum theory will be useful to processing data. Many proposals have emerged, but Peter Shor's proposal, IBM researcher, proposed a way of factoring big numbers using quantum computing. He proposed an algorithm able to use show that an algorithm could do in a very small step than the best classic algorithms could do. So when I talk in a technical way, I always show some numbers. And it's clear that the best classic algorithms, the number of step exponential increase, while his algorithm decreases polynomially in relation to the best classic algorithms. When he proposed that, that was a strike on the community, because using quantic information can have a great application and implications too. For example, classic cryptography would be compromised. In 99, in the 90s, the first company of quantic computing emerged. It was D-Wave that was developing hardware. This company has announced some gains in relation to the classic computer. But what I like to highlight is that 20 years ago, we already had people noticing and investing in this kind of technology. So the first part of this speech is to make it clear that it's not new, although it's kind of old, has already 40 years since the beginning of this discussion. In 2001, there was a group in IBM in California that got a physical system of atoms in a chain with magnetic resonance. It could move the spins in a different way, implementing an algorithm. This is very important in quantic history because it's shown that the theory that was being discussed could be put into practice with gains. We have advantage in relation to what we know in classic computing. Of course, with limitations of hardware in control of the systems, what they could do was factoring the 15, showing that 15 is 3 by 5. Well, we can do that by hand, but they showed that type of computer works, and the steps proposed by Peter Shor is smaller. And if we have a hardware that solve these algorithms with more qubits, we can factor the numbers faster than classic computing. Another benchmark in history of quantic computer was in 2011, 10 years ago. D-Wave, that same company, has launched the first quantic computer, and they made a huge notice. We can do some things in this compute. That's what's nice with scientific community. They check you. What is this computer doing? Is it really quantic? Is it really working with a quantic basis? But naturally, that instigates more research, and then just the fact of launching on the market a computer with all evolution that already had, other companies were interested in that. So other companies like IBM, Google, Microsoft, Toshiba, and other companies started to research in that subject too. So naturally, Google has an interest in this computer search algorithm, other algorithms. So they heavily start to research on that. So 2010 is a benchmark with the introduction of other big companies in the quantic computing. Imagine Google with $100 million being able to invest in high-level researchers. You know, what's going to happen with that? So Google themselves very recently launched the first processor and announced that they had a quantum supremacy that has a huge impact in the community, was stamped in Nature Review with this impactful name, quantum supremacy, and that shook the community again. What is that, quantum supremacy? Some of their discussions was regarding the name itself. Who has defined that? How did they define that? And said they questioned that. So it's not quantum supremacy because you would have been solving a practical and interesting problem. This processor has no interest for the community, has no application. So, and what is the detail? This task done by this processor with conductor qubits, with 53 qubits, they have solved this sequence of logical tasks in 3 minutes. And by that time, the necessary time would be 10,000 years used by Summit, the huge computer. So that's an indication what is that revolution. Because to solve in 3 minutes what in a supercomputer that use a huge amount of energy, for example, this is a very small ship doing the same tasks used in a three quarters huge computer would do. So IBM came to invest and said, that you're saying that you can solve in 3 minutes and saying that we can solve it in various years, we can really solve in 2 days and a half. But even so, from 3 minutes against a supercomputer used in 3 blocks is a huge difference. I didn't show here in this slide, but the Chinese decided that in another algorithm they could solve that problem even in a smaller time. So there is a huge speed, there's a huge run, and a very difficult competition for that quantum supremacy. The capacity of solving a practical problem that no computer can solve, no classical computer can solve. I compare this Google processor, this Sycamore, with the Sputnik. Why do I compare like this? Brigadier, you can answer that. Why was Sputnik used for? To transmit one beep, one signal, and it took 20 days. He spent less than a month to get into the atmosphere again, but it was a benchmark into the possibility of putting a satellite into the space. With this satellite, humanity was able to notice that it was possible to put a satellite into space and do everything we're doing now. As we have seen in the previous speech, we're talking about 40,000 satellites, the world connected. It started with the Sputnik, 5-8 centimeters small one that didn't do anything almost. And now it has revolutionized all areas in humanity. And that's how I see this Google processor. People think that what it has done, China shown that you could be faster, and it has shown that it has posed problems to the classical computer. To do what this little ship has done, you would need a block computer. So more investments were done in the area. In 2015, there was already an international movement regarding quantic technology, communication systems, quantic sensors, around $1.5 billion of investment in the course of 5 years. In 2021, the world investment is around $24 billion, especially to develop the quantum computer. This is the table that shows the initiatives around the world. The United States with 1.2 billion, Germany $3 billion, and so on. China is investment around $10 billion. So all governments start to notice that there is a potential of a computing that can solve problems for us. So they start moving on, highly investing in national programs to boost the area because of its potential. What made us a little sad is that Brazil was in the first map in 2015. It was known as one of the players. And today, no one mentions Brazil anymore. Brazil is choosing to be out of this run. Is it a choice or just lack of planning? That's what I want you to call your attention for. Among those initiatives around the world, there are many. There's in Germany, United States, Holland, Netherlands. I'm in a group in the state of São Paulo of that discussing the possibility of doing a similar program. Because of that, we're studying the quantic initiatives around the world. I particularly have studied the German initiative because I know their people, and they have a system that, in my opinion, we should copy because they articulate government, industry, and academy. And what are they doing? Among many other things, one that caught my attention is they take the government that know the companies, they're creating office to assess the companies they're interested and have conditions to develop in this area. Go to university and assess what are the researchers, and the government articulate them. The government search for competencies and contact them with and help with financing, and the thing goes. Germany is very famous for that technological development, and it's going to happen. That's going to be for a long time, I think. We need to copy that. The United States has always been one of the great developers of technology, and in quantum, it's not left behind. In their initiative, one thing that called my attention is that they have chosen some places, I think 5, to create centers of quantum technologies with high investment from lab buildings and research hiring. There are 5 centers around the United States to make the thing happen. So we see that governments are moving themselves. And beyond governments, we see companies. What did Google do? It created a campus in California just for quantum computing research, hardware and algorithm research. I had the opportunity to talk with one of their directors in this campus that I show here, one of my students that has studied with me for 2 months, that's now working in that Google Center. Via this student, I could schedule an interview with the Google director here. And what caught my attention is that their approach is very different from other companies. They need computing. Everyone knows that. They are investing in that because they need and they know in their vision around 2030 the quantum computing is going to be something very commercial. It's going to be on the market. So they're preparing themselves for 10 years forward. It's kind of medium term. It's not more long term. So they have built Sycamore that have only 53 qubits, but their goal till the end of the decade is having a chip with 1,000,000 qubits. Why 1,000,000 qubits? Because it's the number of qubits that we estimate that are necessary to run an algorithm of Shor, for example. Because to resolve Shor's algorithm, theoretically, you need around 3,000 qubits if they were perfect, but in the real world, because of dissipation and other problems, you have to implement error correction protocols. And so that number escalates to the order of 1,000,000. So they have a definite goal of having 1,000,000 qubits by 2030 to solve the Shor's algorithm. Another company that's on the market since a long time and is investing highly aggressively is IBM. They have a very clear roadmap, and they're following that roadmap. So from 2019, they already have a chip with 27 qubits. In 2020, they were able to do the one with 65, and in 15th of November, they have launched a new chip with 127 qubits. It's a benchmark too, because a qubit with more than three-digit qubits, to simulate them to let them reach a quantic state that classic computer cannot simulate. So the number of possibility when we grow the equations to describe this system, it's such a huge calculus that not even a supercomputer can solve that. So it cannot solve better what a classic computer can solve, but whatever it solves, the classic computer cannot solve. So they're planning until the end of the decade having 1,000,000 qubits. So IBM and Google's approach, I have the opportunity to talk to IBM people too. IBM is a kind of different. They give public access, the qubits, the chips, the most sophisticated chips are paid, very expensive, so it's already being commercialized. They are having profit from those researches. And they're already announcing to have 1,000,000 qubits to the end of the day. There is some blocking, of course they admit, but Google also says that they're very different enterprises. Google doesn't open their system to the public. I don't have access to Sycamore, for example. So they have different approaches. Google is developing for themselves because they need computing. They're investing without minding of having a commercial investment. But IBM seeks profit, and they also talks of 1,000,000 qubits to the end of the decade. So we have to be aware, we have to pay attention, because they both are not they're not having an agreement, so to say. Other smaller companies, for example, they're shaking the market is IonQ. They work in a little different system with imprisoned ions. And what caught my attention is that 2 months ago, they have already opened capital in the stock market, and they have gathered many many investors already. Young has already a lot of investment with they forecast having 1,000 qubits to 24. They're very clean and less errors than both IBM and Google's qubits. So they need less qubits to execute, to run a quantic algorithm. In Google and IBM projects, they can have scale. In IonQ, they cannot. For you to have an idea, China is heavily investing. Look, Jin Wei Pan. Look at this name. He's a Chinese. I would risk to say he will have the Nobel Prize of Physics because he has been extraordinary research. Last year, he has done a photonic computer, photon computer. This is his experimental system. What could he do here? He distributed an random steps. Google said that he said in 3 minutes what would be done in 10,000 years in a supercomputer. He has done in 200 seconds. If it was done in the Chinese supercomputers, it will take 600 million years to be done. So it's not a practical task. They are still not solving a commercial interest, but they're showing it's possible to do things in a time classical computer cannot do. So the difference that I would like to show you is from 200 seconds to 600,000 years. So nowadays, what practical things quantum computer can solve? Nothing. This is a situation in search of a problem. Is a solution in search of a problem. The same the same person that has done a computer to photon can make a computer exactly the same Google and IBM. Has done a ship. He has built a ship with 66 qubits. But in the end, in this case, they could run with 66. They solved in 1.2 hours the same task Google has done, but in a more complex way, according to what IBM could do in 2 days and a half. In a classical computer, the same task would be always we have to have a scale notion. What is done in a computer like that is done in an hour, could be solved in many years in a classical computer. That's a difference in scale that we foresee, we can see in the quantum computer that the classical computer is not able to do. If you factor great number, you have a problem with cryptography. And our systems of cryptography, what happened? The ones we have nowadays, no quantum computer nowadays can breach the cryptography of our nowadays computer. Maybe in 10 years, we will have to mine that. In truth, there's a lot of people already minding that there's a cryptography system post-quantic that's not quantic, but it's robust. And there's also quantic cryptography, which is being done around the world already, and the Chinese person, the Chinese researcher, is doing everything. Quantum computer, he has a research center, and he literally has a blank check. The government pays whatever he wants to do. He wanted to do a communication systems with a satellite. They have launched a satellite. He has his own satellite. satellite in space. Around $100 million cost just the satellites. So he was able to build and published some articles showing the communication with satellites, with fiber, and a network of quantic communication with his system. He has done teletransportation, states sending information to satellites. And to pinch us a little bit, those articles were done in 2017, but it was done on the 7th of September to punch our prideness. IBM sent on the 15th of November and the Chinese on the 7th of September and so on. So this quantic communication, I'm going to do a little marketing here for myself. I have a partnership with the company in Campinas with this research center Herbert von Braun, and we have a broad initiative around the projects we have. We have one project that's already working to build quantic communication. The same thing the Chinese are doing. We're on the first test. We're discussing the first lab test proving the concept. We have a partnership with SCAR University and University of Minas Gerais, University of Werner von Braun, with personnel of physicists, electronic engineer, specialists in twin photons, and so on. So we're also working with single photons generation, which is a status that we need for those communications. And our goal in medium term is to implement that in real conditions in optic fiber in cities, even in highways. Recently, I've been discussing with some friends, a friend that's working with satellites and do commercial ads on satellites, and discuss to do that using satellites, just to prove the concept for a while. And for that, I would like to talk a little more with the Brigadier so that we could join our forces. But that is already in our scope, in our roadmap of quantic communication. Quantic computing. How can Brazil be a player? Maybe I'll change the question. Does Brazil want to be in this game? Because we do have capabilities and competency. You know that better than me. You have many examples, but I'll just get two of them. Two examples that need high-level technology. Embraer, 50 years ago, a group of people decided to build airplanes. Who would compete with Boeing and Airbuses and etc.? Embraer, our Brazilian company, has risked doing that. I've seen a video of a physicist, Neil deGrasse, an American physicist, a great scientific publicist, with Pedro Bial, and he started his interview saying, from 10 flights I get in the United States, 7 or 9, around that, is with an Embraer airplane. So it's a very competitive market with high technology, gets Brazilian technology. Brazil exports that type of technology. So we started a long time ago with incentive of the government, small, and it got a great company. You see, we do KC-390. You see how much technology there is in an airplane of that kind. And I have a brother working in that project. I'm very proud because he's working in that very project of KC-390. So we have breakthrough technology, breakground technology. Another example I like to cite is the particle accelerator in Campinas. We've built the Sirius accelerator. It's one of the best in the world. The level of precision in engineering and technology to build something like that is extraordinary. And they have done that. They didn't start a long time ago. They took 7 years to do that. It's a world reference to characterize material and do a lot of many other things with Brazilian technology. And I could keep mentioning, I've met people in São José dos Campos doing breakthrough technology and ethanol. I could speak about clean energy, submarines, nuclear technology that had that type of technology. So under my perception, Brazil, with around 200 million, with competent people, competent engineer, if Brazil decides to do, it will take some time, maybe decades. Because, for example, Embraer came from the 70s. Brazil has competency, capability to do that. So that's why I'm asking, does Brazil want to be a player? Because it is able to compete. Who would imagine a Brazilian enterprise competing with Boeing and Airbus? Well, it's not competing with the big airplanes, but in the small ones, it's a reference. Where do we want to be? I think it's a matter of governmental policies, support. I think you should think about those programs that I've cited in the United States and Germany to articulate that possibility. What are the benefits of that communication and quantum computing is a matter of security. State security, especially dealing with communications. We know that even the president was hacked. So when we have information, we have everything. So we have to mind that. If we know what a company is going to do, you buy their bonds. If this competitive market, knowing information, you have the control over what you have. You have to have security and capacity to run a lot of information. A word that I use now for the new petroleum is data. With data, you can do projects. So to process information, process data, does Brazil already have that competency? Fortunately, it does. 20 years ago, Millennium Institute was created. From 2001, you have national institutes in quantum information. There is a Brazilian community coordinated by Professor Benita Collen in Rio de Janeiro. You have that at the website information. There are more than 24 labs all over Brazil working especially in quantum, people that dominate quantum communication. Around 14 cities, 10 states, various institutions, 96 researchers. I got that on the website, but for sure it's much more than that. Just in the north region, we don't have researchers there, but I guess there's already people in Pará working with quantum computing, but that's what's in the EINCT website. I know that's probably more people working since 2000s. I had my master dissertation in teletransportation in the 2000s. So I value the initiative of General Camuri that has created a group to discuss quantum technology. That has helped the putting into contact of various researchers to discuss actions, can we work, how can we make this reality. That's how one starts. You know people, you gather, exchange ideas, and I know a lot of good things are going to emerge from that. There are some companies working with quantum here, Senai Cimatec, Center of Quantum Computing Center. There is people in Serna Van Braun, in a startup from São Carlos, and Dobslit. There's also Brazil Quantum, with students from ITA, PUC, and IME, which are study centers in Brazil. They already have a startup founded already. There's the Quambai from Eduardo Duzione in the southern part of Brazil. And I guess there's more than that. Those I know personally, but certainly there's more than that. Beyond that, we are working with an initiative in the state of São Paulo. In August of 2020, we started with 6 researchers. Now we have 40 or 50 researchers to elaborate a proposal for the state of São Paulo that can be used by all the country, all the Brazilian state. To conclude, I'm not sure if I went over my time. I defend national initiative as it happens in India and other countries. We should invest in that. How would we do? Firstly, we have to be aware of false promises. It's a disruptive technology. It comes to solve some problems that classical computing cannot solve, but not all can be solved. So we have to be aware, because we see people saying absurds. For example, in Stockholm, I was with some of my collaborators, and they're working with quantum also. And Professor Anna Petroshevich is already in contact with many companies, and people said, oh, you're using you're bidding on a quantic language, and how are you going to use that type of state crumbled state? It's a technical name. Not anyone know what they're talking about. We have to invest money, and people start to talk. So we have to be careful. We have to have a careful study, talk to people, assess the possibilities, what is, what it isn't, but to have a decent, very well-structured program. It's very important to mine people. We do have people around the universities, but I see the difficulties in São Paulo, the startup. Where is the people? Where's the people that know about it? We have to mine people. We have to train people. Although we have people that's capable of being trained, we still don't have trained people. We have to give support to labs and research groups. China, you see the difference. China has decided to build a center in a JUAPAN center, investing. They're doing quantum communication sensor, quantum computer. They're doing everything. United States has already admitted that the quantum communication is going to be hard to compete with China, because they had serious investment, they thought in a long term. We have to foment the participation of startups and companies. Sometimes they do not know how can better their products with that. You can see the German program. They have offices that research in the universities which one have competencies and capabilities to develop technology. See the demand from the industry, their interest in developing technology, so they articulate so to make the thing happen. Let's get the United States example. They have built 5 centers of quantum technology around the United States. I think Brazil should go to do that the same way. We have to think in long term. See the perspective of Google and IBM. To the end of the decade, have a computer with a million qubits. Although we have to see, otherwise we're going to be just consumers of that technology. If we get to that stage, the United States is blocking some Chinese companies. They're blocking the research centers of JWIPON. They're blocking them for commerce because their technology are being used by the military in China. And that becomes a threat to the United States. So that's why the United States is blocking quantum computing so that it didn't get to the Chinese military. You in the armed forces understand that. You don't want your enemy to develop better technology than you. So quantum computer used in the military field, I'm not sure if the United States will be happy if you use that. But that's a question of sovereignty, communication. We can buy equipment of whatever industry, but what's there in that equipment? What's the warranty? What's the safety that this information is not being spread all over? I don't understand very much of this communication system, but I ask myself, how do Americans know everything we do? You in the information department might know better than me. So those are some things that can be done, that can be thought in a broader perspective, calmly, calling, talking, having chats with the community. That's a long-term project. It's a state project. It's not just 3-4 years of government. I believe Brazil is competent. Brazilian economy is strong. We are capable of doing. The question is, does Brazil want to have it? Does Brazil want to be a player? Thank you for your attention.
Ladies and gentlemen, thank you very much to Professor Celso for his presentation. I ask the audience if you have any questions to the professor on his presentation. Very well. Thank you very much, Professor, for your time, for being with us. It's been a privilege hearing you. Thank you for your time and attention. So now to continue, we have one more presentation. Once again, thank you very much for Professor Celso for joining us. And now we'll have the privilege to hear out Professor Dr. Johnny Marquez with the Technological Institute of Aeronautics. I would like to invite the professor to join us on the stage. Please join us, be welcome, Professor Johnny Marquez, and the theme of his presentation is the role of innovation on development and certification of military aircraft softwares. This is the theme that will be approached by Professor Johnny Marquez. Make yourself at home, Professor. You have the floor. Thank you very much.
Bom, pessoal.
Well, everybody,
Bom, pessoal, boa tarde.
good afternoon,
Hoje eu vou falar
and today I'm going to speak to you
assunto que eu venho
about
pesquisando
a
há algum
subject I
tempo,
have been
que
researching
é
for a
o
while,
papel
that is the role
da inovação
of
e da certificação
innovation
de software para
on
aeronaves
software
militares, né? A certificação de
certification
software,
for military
ela
aircrafts.
já
Software
acontece
certification
de uma
has been
maneira
happening in
bastante
a
bem
very
estabelecida
well-established
para as
manner
áreas
for the
de
fields
aviação
of
civil,
aviation,
né?
civil
Os
aviation,
aviões de transporte aéreo
the
regular,
regular
os aviões da
transportation
aviação
aircrafts and
executiva, da
executive
aviação
aviation
agrícola
aircrafts,
e etc. E na área
agricultural
militar, a gente
aviation, etc. In the
tem uma
military
série de
field,
características particulares, né?
there are a
Uma
series
delas é
of
a natural
particular traits.
preservação,
One of
né,
them
das informações, né, que são
is the preservation of
colocadas
information
dentro dos softwares que são
embedded in the
embutidos
software
dentro das aeronaves militares,
inside the
visando o
military
cumprimento de
aircrafts
suas
aiming at the
missões.
fulfillment of their
Então eu separei
missions.
aqui um conjunto
So
de
I have
slides
separated for
para
you
ilustrar um
a
pouquinho
set
por
of
que essa
slides to
temática é uma
illustrate
temática
why this
relevante.
theme is relevant.
Então, quando a gente faz uma análise sobre conceito de certificação,
So when we
em geral as
analyze the
pessoas
concept
pensam
of
que é
certification,
simplesmente a emissão de um
people used to
certificado,
think that this is
né?
just
Quando na
the emission
verdade a
of a certificate,
certificação ela é
when
muito
in
mais
fact
do que
certification is much more
aquele papel, né,
than
que
a piece
dá
of paper
ali alguma autorização ou algum pedigree para aquele
that
produto que recebe
provides a
certificado,
pedigree
né?
to the
Então a
product
certificação ela
that
tem
is
tudo a
certified.
ver
So
com
certification has
o
everything to do
aspecto
with
envolvido na
the
qualidade, na
aspect, with the
confiabilidade
aspects
e
of
principalmente na área de
reliability,
aviação, no aspecto de
conformity,
segurança
quality,
e
and
para a área militar também o cumprimento
security,
da missão,
and in the
né?
military field
Então, se a
also
gente
the fulfillment of the
olhar essa
mission.
diferença entre esses três
So
conceitos,
if you look at the difference between the
qualidade, na
three
verdade, ela
concepts, quality in
significa, né, na
fact
literatura,
means
isso
in
já está muito bem
literature, this has
estabelecido há
been very
vários
well
anos,
established for many
conformidade com
years.
os requisitos.
Conformity,
Ou
quality
seja,
means
para você
conformity with requirements.
definir o que é
Meaning,
qualidade, que é
for
um termo
you to
bastante
define
subjetivo,
quality, which
você
is a
precisa
subjective
definir uma
term, you
qualidade
must
com uma
define
referência, né?
quality
Então tem um
with
conjunto de
references,
critérios
with
que definam
criteria.
que aquele
So what are the
produto
criteria that
possui a sua
define that a certain
qualidade
product
é baseado numa
has
conformidade com
quality
aquele conjunto
based
de
on
critérios.
conformity with a set of
Já a
criteria?
confiabilidade, na verdade, ela é a qualidade
Reliability
no
is
tempo, né?
quality a
É o
long
quanto que aquele
time. It
produto
means
fica em uma operação
when a
bastante
product is in
madura,
operation, in
né?
a mature operation,
Apresentando a
how long
performance
can it
que
maintain
ele
the same
foi projetado para.
performance it was
E por
projected to
fim, a parte
offer?
de segurança, né?
And finally, regarding
Colocando aí esse
security,
viés da área militar, o cumprimento da missão, a
the accomplishment
segurança e
of
o
the
cumprimento da
mission,
missão é a
security
confiabilidade no uso.
is
Ou
reliability
seja, o quão eu
in
posso
use, meaning
confiar naquele
how
produto de software
far can
para
I
que ele
trust that
desempenhe
software
a
product so
missão
that it
que
will
ele foi
fulfill the
projetado
mission it was
para
projected
conceber,
to conceive,
também mantendo a questão de segurança por se tratar um produto aeronáutico,
at the
né?
same time remaining
E
safe
uma das
since it
coisas que
is an
surge por trás desses
aircraft
três conceitos
device.
é justamente porque a
And
qualidade do produto
I'm using these three
ela
concepts
aparece
because
mais
the quality of the
facilmente
product
quando a gente
becomes
tem
more
uma
evident
qualidade no
when we have
desenvolvimento,
quality
né?
during
Na
development.
verdade, tudo na nossa
Meaning,
vida que a
well,
gente faz um
everything
pouco
we
mais
do in life
planejado
that
ou
is
um pouco mais
planned, that is
organizado, tem
more
uma maior
organized, has
chance,
greater
né,
chance
de sucesso,
of
né,
success.
de êxito quando você tem um planejamento ali, né?
You are more likely to
E o
succeed when you
desenvolvimento
plan.
disciplinado, né, que traz
So
essa qualidade no
disciplined development,
desenvolvimento,
which brings this
ele faz
quality
com que o produto
to
seja também muito
development, it also
conhecido,
makes the
né? A
product
partir do momento que o
to become
software,
well
e a gente está
known.
falando
So when
aqui
the
de
software,
sistemas
and we're talking
naturalmente
here about
complexos,
naturally
né?
complex systems,
Que tem times
when
grandes trabalhando no
with large
desenvolvimento de
teams
software, várias
working on the
equipes,
development
né?
of software, many teams,
A disciplina, a
discipline,
repetibilidade, o registro de
repeatability, the
conhecimento sobre
record
aquilo
of
que está sendo
knowledge about what
desenvolvido,
is being
ele
developed,
vai
it will
produzir
produce
conhecimento que
knowledge
fica retido
that will be retained
naquela
in
empresa que está fazendo seu
the company
desenvolvimento, né?
that is
E
developing
isso,
the
obviamente,
product.
vai
And this
induzir a
obviously will
confiabilidade.
induce
Quanto
to
mais eu conheço o
will lead
produto,
to
mais eu
reliability,
consigo
because the
explorar
more I
suas
know the product,
vulnerabilidades
the
e
more
suas
I can explore
fraquezas.
its
Então, a
vulnerabilities and
confiabilidade com a
weaknesses. So
qualidade, ela vai melhorar a segurança
reliability
e o
with
cumprimento da
quality will
missão.
improve
E é por isso que
security
a
and the
gente
accomplishment
justifica a
of the
necessidade
mission. And
dessa
that's how we
temática.
justify the need for this theme to be
Bom, como
approached.
eu citei aqui,
As
né,
I
existe
mentioned,
histórico bastante bem
there is
estabelecido de
a
certificação de
well-established
software na
history of
aviação
software
civil. Na
certification in
verdade,
civil
esse termo,
aviation,
né,
and this
certificação de
term,
software embarcado aeronáutico, ele nasceu
aircraft
por
software
necessidade
embarked
da
software
introdução de
certification came
software
from the
nos
need of
sistemas de
introducing
aviões mais
software in the
modernos, né?
systems
A
of
gente já
more
tem
modern
registros
aircrafts, and we have
de
records
inserção de
of
software desde
insertion of
projetos de
software
aeronaves do início da
since the
década de
beginning
80,
of the
que na verdade foram
1980s.
projetadas no final da
Those were
década de
projected in the
70.
end of the
E na aviação
1970s, in
civil isso
fact, and in
criou-se
civil
um
aviation,
arcabouço mais bem
a framework was created
estabelecido por
that
conta da
is well
característica
established due
de
to
um
the
produto
characteristics of
de software embarcado aeronáutico para um
an
avião.
embedded
Ele vai
software, aeronautical
frequentar
embedded
vários
software that
aeroportos em
will
vários países,
be
cumprir com
used in
legislações
many
individuais em cada
airports
um
in
desses
many
países em que
countries with
opera.
the
Isso,
particular
obviamente, é
laws
um
and
item de
frameworks in
preocupação
each
da
country.
sociedade
And
voar
this
com
is an
segurança.
item of
No
concern to
Brasil,
society to be
desde a
able to
criação da
fly
ANAC em
with
2005,
security.
né,
In Brazil, since the
a
creation of
ANAC vem
ANAC
cuidando
in
da
2005, ANAC has
certificação dos
been
produtos aeronáuticos
caring
para a aviação
for the
civil,
certification
especificamente aqui no
of
Brasil,
aircrafts,
por nós termos indústria aeronáutica
specifically in Brazil,
brasileira
because we
bem
have
representada por
an
Embraer e
aeronautical
também
industry that's
por
well
outras
represented by
empresas
Embraer and other
que vieram na
companies
esteira.
that also
A
um,
ANAC ela tem a prerrogativa de dar
developed a long time.
a
ANAC has a
certificação
prerogative
inicial
of
nas
offering
aeronaves
initial
produzidas no Brasil,
certification to the
para que
aircrafts
depois elas
produced in
sejam
Brazil so that
reconhecidas
they will be
internacionalmente
furtherly
nas demais
recognized
autoridades,
by
né?
foreign authorities.
Especificamente sobre a aviação
Specifically on
civil, o
civil
foco da
aviation, the focus
certificação é
of
só a
certification
segurança.
is security.
Então, se algum
So
avião
if any aircraft
ele tem um software que, se ele tiver um mau
has a software
funcionamento, ele
with
não corre
malfunction
riscos
and
de
there is
causar nenhum
no
impacto nos
risk
seus
of causing
ocupantes,
impact to its
ele
occupants,
naturalmente vai satisfazer
naturally it will
a certificação de
satisfy
software aeronáutico
software certification
embarcado.
criteria by the
Quando
Air
que,
Force.
na própria aviação civil, a gente também tem a
So in
necessidade
civil
de
aviation, we
igualdade entre os
also have the need
fabricantes,
of
né? A gente não pode exigir mais do
equality
fabricante
amongst
A ou do fabricante B,
manufacturers. We cannot demand more
simplesmente
from
porque
this or
esse
that
fabricante é do
manufacturer
país
just
A e
because
outro país
they
B.
are in country A
Por
or B.
isso, foi estabelecido já há
With
alguns
this,
anos a norma
a few years
RTCA DO
ago, the
178C,
RTCA
que eu tive a oportunidade de participar do comitê de
DO
elaboração da versão C, que é a
17838C
quarta
was
versão da
established
norma,
and implemented.
que é uma
I
norma que é
participated in
utilizada
the
para
fourth edition
certificar
of the norm
software embarcado nas
that is
aeronaves
used to
de todos os
identify
grandes
software
fabricantes aí
embedded
no mundo,
in
altamente
aircrafts by
reconhecida
different
pelas autoridades
manufacturers
de
all over the
certificação.
world, and it's
Quando
highly
a gente
acknowledged and
vai para a
recognized
aviação
by
militar,
authorities.
a
When we
aviação
talk
militar ela tem
about
uma preocupação
military
diferente.
aviation, there is a different
Por quê?
concern
Os
because
projetos têm uma
the
necessidade de
projects have
restrição das suas informações. A gente não pode
restrictions
dar
in terms of
publicidade,
information that the information
detalhes,
about the
né,
projects cannot be
sobre
disclosed.
algumas
We cannot
condições das
give
certificações
details to the
militares, né?
public
É
about
claro que
those
existe alguma
projects. Of
publicidade,
course,
né?
there is some
Acabamos de ver
publicity.
uma apresentação
We
aqui
just
que
heard a
falou um pouquinho da
presentation here
Embraer,
about
mostrou o KC
Embraer
390.
and
Eu mesmo tive a oportunidade de trabalhar na Embraer por
KC-390.
15
I
anos
worked
antes
at
de vir para o
Embraer for
ITA.
15 years before
Mas é
working
um
with
mundo
ITA,
diferente, né? É
and
uma realidade
this is a
diferente.
different world, a
Os
different
projetos
reality.
militares,
The military
apesar deles
projects,
terem
despite
alguma
being
comunalidade entre as forças de vários países, eles
presenting
têm
common
todos eles
characteristics
as
between
suas
forces of different
especificidades,
countries,
né?
they each have
Então,
their own
quando a FAB
specificities.
compra
So when
o
the
gripe
Brazilian Air
para
Force buys
operar no
grouping
Brasil, ele
to
tem
operate in
sistemas
Brazil,
que estão
they have
especializados para as
systems
necessidades das
that are
missões
specialized
que foram
to the
contratadas no
needs
Brasil.
of the
E na
missions that were
aviação
contracted
militar,
in
a gente
Brazil. And
tem,
in military
quando
aviation,
requerida, uma
whenever
certificação
requested, we have
orientada para o cumprimento do
certification
contrato. Ou
guided
seja, o que
towards the
foi
fulfillment of the
contratado pelaquela
contract,
força
meaning what was hired
será
by that force
avaliado
will be
na
assessed
entrega daquele
in the
produto
delivery of the
ao longo do
product
tempo de desenvolvimento.
along the time
E o foco não é
in which
apenas
it
a
is developed.
segurança, né?
And it's not
A
focused just
segurança
on
ela é
security.
importante,
Security is
obviamente,
important, of
mas
course,
sistema
but a
militar ele
military
precisa
system
ter
needs to have
uma natural,
a
um natural
natural
comprometimento com a sua missão,
commitment to
né? Ele
its
precisa ser
mission. It
confiável com
must
aquela
be
missão,
reliable,
mesmo que
even though
se a missão.
the mission is not accomplished, I also must be concerned with the security of the tripulation or the content that is being carried by that aircraft in that mission. Another point, another thing that's natural in military aviation is that it is naturally the technological birthplace or cradle of new technologies. Often when new technologies are presented, civil aviation already when to civil aviation, those projects were already implemented in military projects because the military projects involve concern with society and the use of more well-established technologies that have gone through military assessment. This is a pedigree for the good development of civil aviation projects. And military certification, because it is guided by a contract, those contracts change. And every time there is a certification project, we might have different references on how to certificate the software that is embedded in that specific project. So just for us to understand what happens in civil aviation in terms of differences, in civil aviation, normally we define how we're going to treat the rigor of the development of a specific software. I need to perform an analysis of the system's functions and the possible failures in those functions. When I analyze those possibilities, they're classified in 5 levels. Catastrophic, that would lead to the loss of the aircraft, meaning if the software embedded in this system malfunctions, this may lead to an event that will lead to the loss of the aircraft and the occupants, all the way down to dangerous, which leads to fatal injury of or serious injury or just discomfort or lack of impact and the full security of the aircraft. So for this classification, we use this table right here, where I list for every system all the possibilities of failure, and I do an analysis with the performance. I analyze the performance of the tripulation and passengers and the profile of the aircraft. Thus, I can classify the fail possibility according to DO 781C, which is the regulation in civil aviation. Given one of these 5 classifications, I have a level of software embedded from the more rigorous B, C, D, E levels. From then on, exemptions are given in the process of certification of the software. And this all leads us to associate the fact that in each aircraft I create failure possibilities. They are unfolded in different systems. For each system, I perform an analysis similar to that table. I classify that analysis. And when my system is purely physical, hardware, mechanical parts, electronic parts, hardware, mechanic and electronical parts have lifespan, so I can estimate the failure probability because the hardware will die, if you will. They will cease to work at a certain point, and softwares don't cease to, the softwares don't die. Softwares, in fact, do not fail. They do whatever they were programmed to do. And when I need to find out what was the inadequate behavior, I need to change the software, which generates something else and not something equal that will substitute the same thing but with a failure. So before we move on, then we established in civil aviation a norm that enables dialogue and enables us to request the companies to deal with software specifications. This analysis has 5 levels. For each one of these levels, from A to E, we have a set of items that is called objectives that need to be satisfied. So for level A, this is a software that if it malfunctions, the aircraft will be lost and we will lose the crew and the passengers. I need to comply with 71 objectives, which is the entire norm. If I have lighter failure classifications, B, C, D, etc., I will have exemptions that will reduce the rigor of the certification process until impact of security. Many of you have traveled by airplane abroad and so on, and they have an entertainment system. As in an entertainment system, doesn't cause any security problems if it does not work. So originally in the certification process, it does not have to meet any of the objectives. What may happen is that this may give the liberty of the company of producing a system that doesn't work or that lacks quality. However, for the passenger that's going to take a trip of 10 hours crossing the Atlantic without an entertainment system, that trip will be very boring and difficult for them, especially if it's during the day. And the air companies have to deal with this kind of complaint. I worked in 2 airlines before I worked at ITA, and the airlines are concerned. They want these systems to work very well, even though they're not aiming at certification. So we can establish a comparison that some systems of civil aviation must not be treated in the same way because they affect the operational part and the comfort of the patient that has paid an expensive fee to travel as a part as a to be a passenger of that aircraft. So in the military, we have, dealing with the military organizations, we have different contracts with different impacts, economic, financial, and the objectives of the missions themselves. So is in this aspect of software development, to bring quality, we must consider that we do not we don't have the possibility of developing one single software. We have to work on upscalable solutions that can be simpler than in civil aviation, but that also offer the minimum guarantee criteria for the accomplishment of military missions. So since the softwares there's not just one way to develop softwares. Along the years, software engineers have created many models of lifespans, cascade, incremental. Nowadays, we're talking about the agile models which can be used with this kind of software with no problem as long as items are suggested, value items are added for certification. But these softwares go under many processes in their nature in the field of development. Typically, we'll begin with a call for requirements, then we detail the software design, then we do the implementation to transform the equipment into program language, and that must be certificated and validated by tests, inspections, and so on, especially for a system of this nature that has a security bias and also a mission bias, considering civilian and military are different in cost and expectations, so we must have this product must have intrinsic quality. But there is no magic formula for this, so we created a framework for innovation within my work group, and in terms of methodology and processes made by ITA. These are the lifespans, as I mentioned, just to give you an idea of how those processes of software engineering can take place a long time. This is the cascade effect that is sequential. You start using a software since the beginning of the specification of the software until final verification. There's an incremental model where add little releases of the software. The modeling way where you use every level of specification at different level, and the more exploratory spiral format. All of this is known in software engineering literature. This model for innovation is proposed for military certification. It has two publications done by our group. One was published in CIGI 2019, an event that happens at ITA annually, a symposium on operational analysis, where we did a survey on requirements of processes for certification of military systems with softwares, and another set of requirements for certification of airborne military software. São José dos Campos is responsible for the certification of many FAB Air Force systems, and we did a version of this work in English that was presented in the DASC 2019 or 2020, which is well-established event internationally sponsored by E3E. How does this work, this model for certification, this reference model? We start using criticalities analysis and severities and probabilities using the MIL standard 882E that does risk analysis to identify security items and consider the mission accomplishment demands, because we take risks assuming this is a military. We know that military missions will risks are involved. Now we have two requirements. 20 of them are demonstrated by the manufacturer of the software. We call in the certificate area, we call the requirer, the person that is requiring the certification. That is demanding the certification of that product. The complete set would be those 20 for the applicant, and they will be minimized as I reduce risk in each one of these colors over here between high, serious, medium, and low. And even at the low level, we have requirements to fulfill differently from the case of civil aviation, when at the E level it is allowed for you not to do anything, any kind of development in software, which obviously will compromise the quality of your product. Well, this software, once existent, it is sent to the applicant, that aircraft, that airplane or helicopter, and it is sent to the authority that will issue their demand based on the meeting of the requirements. So this is a model we're started using or testing. This is a concept we're doing concept proof, and we expect to be using this in future contracts. We celebrate obviously where we can influence the process to be able to mention or not certain norms, because this often makes it very difficult for us to implement the process of certification. So how does the ITA, how can we help you in software development? We have a field of computing science that's very well consolidated. We're very proud to have been gotten the first place in the last ENAD in computing engineering. Those are our courses, and our average rating according to the Brazil ranking of this course, and we are 50% larger than the average computing courses. We have won many prizes. We have, the most recently was in the state of São Paulo, where there's the Guia Quero Estadão, the five-star guide that replaced the previous one published by Editora Abril, the publisher Abril, until 2018. At ITA, apart from our publications, we do research at the master's and doctorate degree levels, and those train people from the three forces, the air forces, which are the largest, the ones that are the most the larger part of our public, but we also have professionals from the Navy and the Army, and we are very proud to promote this environment of training that involves all three forces of our country. Also, there, besides our post-graduation courses, we have trainings for civilians. We have the academic training that is offered at the same time as PPGAO, PPGAO, and recently we have opened courses for the industry, which is the professional training master's degree in aeronautics computing, which is a course that teaches computing for the Air Force. We're working to provide services to the Air Force. It is telepresential or it is a night as an evening course, and it will bring more computing into the Air Force through extensive training in this field. We also have our group on interest in methodology and software development in the Department of Science and Computing of ITA, known as GIMPS. We have 3 professors, 6 PhD students, 5 master's degree students, and 3 undergraduates. 60% of the research involves software certification, and we have civil and military students from 3 forces, and we are the institute that's certification institute that certifies air and space products. We have the presence of military and civilian students at different levels of education. I invite you to check on our website our mission, our vision, our research, and our publications, our team, and the ongoing research. We also have scientific production, which is very interesting for a group that has been working for a little over 2 years. We have 46 publications in different areas that includes complete books, chapters of books, journal publications at ACM, the international and national papers, journals. We have this gives visibility to our findings. We also have created recently another research group in 2020, a group that is formed mostly by professors, and we are beginning to include our first post graduation and graduate students. We are working on autonomous search systems and physics cybernetic systems. We have these 2 projects in this group, and the first one demonstrates systems for search and rescue, autonomous search and rescue missions, manned and unmanned, using the image system target search based on image, and the other project is a project for the delivery of last mile delivery drones that are those that do the last arm of delivery of any kind of delivery. This is done by drones, and this supports decentralized blockchain. It is a concept proof, and we have done a publication on this, and our group is gaining strength in this area. Also, we are promoting consultation in software certification. We support the KC390, Gripen, IFFM4BR, Phase 2, VUY, an aircraft by PEV and its modifications, and the modernization of E99M. I had the chance of offering consultancy through our organization to Gripen last year. I worked with many auditorships, many audits. I support IFFM4BR, so we can offer the support to the Air Force, which is the case of these 5 projects, but also to the companies that need to demonstrate these certification criteria within their projects with ANAC and the military authority. And how does the improvement of processes of development of software help in military technology? Through the retention of knowledge during the development of software. We need this in aviation projects in general because we're not doing a project of a short duration. It's not like projecting an app on your cell phone that will work for 3 or 4 weeks and then it will be discontinued. An aircraft is planned to fly for 30, 40, 50 years, and in military aviation this is much more common than in civil aviation. So having good knowledge of the development allows us to do maintenance and furtherly modernizations. So I see these projects of modernizations that start, and as you try to modernize them, modernization is usually cockpit modernization, as recently happened in all the Air Force Bandeirantes, but sometimes the absence of documentation on how those projects were originally developed does not help us to know the functions that were conceived, how they existed, because they will need to be portable to be modernized. The most modern plane cannot do less things. The capacity must be expanded, but for this to happen, we need to know what it was able to do before so that modernization can be successful. So this will help those processes, and we can see that modernization is a constant work, a continuous work from now on, and software will be a constant part of modernization. Also, good knowledge offers good maintenance during the lifespan of the product. Appropriate documents must must add value, describe functionalities, functions, applications, and settings, capture the problems, approach the problems, how they were resolved or mitigated. And this is a natural need. And we need to focus and test capacities. This is a code and not code. And to test capacities, I must have references, I must have descriptions, requirements, etc. And finally, I believe that despite our bias on software of third parties and software for the air forces, as was presented here, there is validity not only of this work but other works in terms of defense. Other Air Force products, vehicles as tanks, vessels, satellites, rockets, those medical devices, vehicles. There are similar norms for certification as for the civil sector, but all those products here are complex and they are used for specific missions. So we need to ensure that these softwares are reliable, quality, and certified. So for my final thoughts, I gave you the brief contextualization of the military and civilian air software certification. I gave you the need of a model of scalable reference for the certification of military systems, where we intend to influence the use of this model in future contracts if we manage to do so, because I think this will offer a controlled repeatability of the certification process, and we will consider the effects of abnormal behavior on the impact of the mission. So, since we're working with military systems, you will do security analysis, and that military system often does not knock down an aircraft, but it will not justify the aircraft. So operations. So I need to do certification so that it doesn't have to have quality in its development necessarily. If it doesn't, this is what instigated us in our research project, and this is what has been keeping us going. So this is what the slides, those are the slides I had to say, to show to you, and I am at your service for eventual questions. I leave you my contact info, and I invite you to come meet my research group or get to know us online. You will find us easily on the web. Thank you very much. Thank you, Professor, for your presentation. Ladies and gentlemen, do you have any questions to the professor? Is this the case? Well, this is not the case. So, Professor, once again, thank you very much for your presentation, for sharing your knowledge with us. This was very important to our event. Thank you. Thank you for your invitation. Ladies and gentlemen, we are now coming to the end of our work, and with this lecture we finished our program and our activities of this event. Our program, the complete program of the conference on systems and military technology, CSTM 2021. We would like to thank you, ladies and gentlemen, who followed us in the auditorium during these last 3 days. Thank you very much. Thank you all to you. Thank you all who followed us remotely. Thank you very much. You who have access to this recorded to the records of these lectures. Thank you also for your